दिखाई दे रहा है कुर्ता भैया कुर्ता का थीम चेंज हो गई कुर्ता नहीं लग रही
Okay, so hi everybody, welcome to Design Interventions. We're really glad you could come to the workshop today morning. Can you all hear me clearly, by the way?
Yeah.
Yes.
I'm sorry for that. I just had the YouTube live streaming link also switched on. Seems like there's a little bit of lag in that. Okay, so before we start today, let me just brief a little bit about design interventions. We are an educational consortium comprising mainly of architects and designers. And we aim at sharing our computational knowledge and skill set among architectural students and professionals. We have been doing that for the past 3 years. And over the period of time, we have been able to reach to more than 4,000 participants. And we have been doing that by conducting workshops, webinars, and talks, just like today. So today we are going to have a 4-hour webinar session. So it's just a small introductory session to get an idea of what is parametric architecture and how to use tools like Rhino and Grasshopper, and what are the possibilities that the tools have to offer us. So let me share my screen and let's have a small presentation to understand what exactly is parametric architecture. Okay. So what is parametric architecture? Parametric architecture is nothing but a design workflow where your end result is manipulated by certain parameters. And these parameters would be responsible for the form and the function of your design. So changing any one parameter is automatically going to give you a very interesting result. In simpler terms, what it's going to do is you are the user. You will set certain parameters which will run through an algorithm, giving you an end output. So when you do that, just a second. Okay, so when you do that, you will get an output and you will analyze the output. And if you're not happy with it, you will once again change the parameters to generate another output. So you keep on repeating this process to generate n number of possibilities and outcomes, and then take a call on what would be the best result. Now, there is another thing you can do in addition to it, which forms the basis of generative design, which is nothing but introducing a genetic solver within the software or within the tools, which will help you achieve these kind of parameters. And the genetic solver will now start to change the parameters by itself to give multiple outcomes. So that way you just need to visualize and see what is happening and take a call on what is the final result you want to work with. Let me do one thing. It might seem too much to be, going around your head a little bit. So let me just share a Grasshopper script with you, where you clearly see what is the parameters we are talking about and how an algorithm is able to visualize a different outcome. So I think you can see my Rhino and Grasshopper interface and screen. And we have the example of a very simple architectural element, which is a column. Column has three parts. We have the base, the shaft, and the capital. There are two varying elements, which is the radius of the base and the height of each element that is in the column. And if I change certain parameters, so parameters is whatever I mentioned right now, that is the radiuses and the heights. When I keep changing the parameters and pass it through an algorithm, which is in the center, and visualize the final output, I will get something like this. And once I visualize, if I once again go back and change the initial parameters, you can see that the form is now starting to develop into giving me more and more options. So this is something to do with as simple as an architectural column. But let us say you are going to be working with more complex elements, or you are going to use these strategies to design an entire building, then the possibilities are pretty much endless and you have so many design options to choose from and finalize on what is the best result you want to work with. And we also have one more algorithm here. So this is an algorithm just to evolve the form, like different variations of it. Once we are done with it, if I switch on the next algorithm, and take a look at the output, it's basically going to give me the fabrication data of it. So how each piece of the column needs to sit together. I'm going to get a visualization of the same. And again, I can change certain parameters in that. So if I change the thickness to a slightly different value. So if I just change the thickness to, let's say, let me give a higher value here. And change it. You can see I can change the method of fabrication I'm using as well. So this is what we mean by parametric design. Rather than the traditional workflow where we are going to be physically creating models, we are just going to work with parameters. When passing through an algorithm helps you to give a different kind of result, right? Okay, so let us go back to the presentation. And to understand this concept a little bit better, we have cited two examples for you. One is taken from the early 1900s. The example is called as Sagrada Familia. It is a very, very interesting example that is ideated and executed by Antonio Gaudi. So in the early 1900s, we know that definitely there are no parametric tools. We don't have things like computers or softwares to help the ideas get visualized. So what the architect had done was he had created an elaborate physical model. The concept he wanted to experiment was to do with catenary curves. And what a catenary curve is nothing but, if you look at the left side bottom of my screen, you will see that a chain is suspended freeform due to its own weight and gravity. And when it is suspended freeform and anchored at two endpoints, it will form a natural curvature. This curvature is called as a catenary curve, and it is stable in terms of tension when it is hanging down. But the same curve, when it is inverted, the form is going to be very stable in terms of compression. So that was the idea the architect wanted to experiment and explore in his entire design strategy. So to do that, what he had done was he created a physical model, which is the one you're seeing here. So you can see a very elaborate physical model where he had used multiple strings with some bags of weight hanging at varying lengths and varying frequencies and varying distances, giving a very, very elaborate physical model like this. And what he had done was he had taken a photograph of the physical model, inverted the photograph, used it as the basic element to sketch the design of the entire church. So you can imagine the amount of intense thinking process the architect might have to use in that period of time with very limited resources to come up with this structure. And it's a very, very interesting example. But why we are citing an example from the early 1900s is because the thinking you can do at any period of time. You don't necessarily require any tools for you to be creative and come up with your own parameters. But with the help of tools, it is going to make that process much, much easier and accessible for everyone. Let me show you an example of that in Grasshopper as well. Like if you were having access to these tools, then how easy achieving this would have been. So I have another algorithm here where we have certain parameters like the length of the string, the weight of the bags, the direction in which the curve is formed, and etc. And using that, I have an example where we can simulate catenary for a single curve. And I can flip the direction. So if I flip the direction, it is going to go in the natural weight with respect to gravitational force. And if I flip it to the positive direction, it is going to mimic the inverted catenary arch, which is stable in terms of compression. Also, I have other parameters like changing the weight of the bag, changing the length or the elasticity of the string, so on like that. And when the same algorithm passes through a more elaborate set of curves, this is the output we would be getting out of it, something like this. And again, we can change the things as I had shown you before. I can flip the direction and you can see that the entire design the architect had visualized, taking years of time, is possible with just a single click in the software. So this is how the tools have helped everybody to access these kind of design strategies. Going back to the presentation, we have one more interesting example taken from today's modern day parametric design experiments. So we have an example from the Tulum railway station. And one of the interesting strategies that they have used in their design process is incorporating environmental factors to make sure that the form or the details or the design outcomes that is achieved is more comfortable for the users within. So what they have done was they have analyzed the roof that they designed for the amount of radiation, thermal comfort, and other factors. Once the analysis is done, they have it color coded where red color indicates the hottest regions and the blue color indicates the coldest regions. Once they have analyzed the conditions of the roof, what they next did was they came up with a strategy where the size of the fenestrations and openings is going to be determined by the amount of heat radiation or the comfort inside. So if you notice closely, you can see that wherever the radiation is higher, that is in the red portion, you can see the size of openings to be much smaller. And in the cooler regions, it is going to be much bigger, responding to how the environmental factors are. So when you look at this example, it is not something that can be just ideated with our concepts. We definitely need some parametric tools to be achieving these kind of concepts, because if I were to physically figure out based on the sun path and theorize that certain areas are going to be hot and cold, the accuracy of that is going to be very minimal. I cannot guarantee the accuracy that it's going to be responding perfectly to the amount of the radiation or the environmental conditions. So when you have more complex parameters, it almost becomes mandatory to have certain tools in order to achieve that. And that is where we have two tools, Rhino and Grasshopper. There are many other tools available like Maya, Revit, Dynamo, Blender, etc. But amongst all the different tools, I would say Rhino Grasshopper is one of the best tools available out there in the market. It is also the industry standard across the world. Why? Because it is one, accessible for everybody. And second, the amount of users are really high, which means your access to resources, plugins, or any issues you're facing, you have a community to look up to who can help you with figuring out the problem for that. Right. So this is just to give you a basic idea on what is parametric architecture. Now in today's workshop, what we are going to be doing is we are going to be seeing how to use these tools. So even if you are a complete beginner, it's not at all an issue. I would be starting off with the interface, just giving an idea of some basic tools that would be necessary to go about the session today. And once we understand the interface and the basic exercises, next what we would be doing is we will be seeing a workflow where we create an interesting facade and then manipulate with certain parameters in Grasshopper. And also another workflow where we will start generating different forms in Grasshopper and also get the final fabrication data of it. So this is the plan for the webinar today. And let me just stop sharing the screen and open my Rhino and Grasshopper. So guys, I hope all of you have Rhino 6 or Rhino 7 installed in your system. If you have it installed, feel free to open and work along with me. Why? Because I would be going at a very slow pace. So even if you are a complete beginner, it won't be much of an issue for you to follow along with me. So let me just share my Rhino Grasshopper screen. All right. And when you're going to be working along with me, if you have any questions, any doubts, you missed out anything that I said and you want to get some help on what was the tool used, feel free to message in the Zoom chat or in the YouTube chat. So it is being streamed live in YouTube as well. So you can type it out in that chat. We have a few of our team representatives out there to help you guys with any queries that you're having, right? So make sure you are able to practice along with us, because at the end of the day, you do definitely want to have some interesting outcomes, and we would love to see what you guys can generate from the strategies we'll be seeing in class today. So first, I hope all of you can see my Rhino screen. In Rhino, the first thing you will notice is there are 4 different views. You call them as viewports: the top, perspective, front, and right. And if I create any one object in any of the viewport, automatically I can visualize the plan, elevations, and the 3D model of it in all the 4 viewports. Now, if I want to work only in a single viewport, then what you can do is move your mouse to the name of the viewport, double click on it. It is going to expand into a single viewport. If you don't want that, you want to toggle back between the 4 different viewports, go back to the viewport's name and switch back to, just double click on the viewport's name and it will switch back to 4 different viewports. So to toggle between single and multiple viewports, you just need to double click on the viewport's name. Now, the next thing is, let me go back to a single viewport itself. Now, the next thing is the style in which you're viewing. I have a box drafted in front of me, but we don't really see the faces of the box yet. We just see the edges or the outline of it. That is because we are viewing in a style called as wireframe. If you want to change the style of viewing, just click on the small arrow next to the name of the viewport. Under that, choose Shaded. It will automatically give you a preview of the faces and the edges. You have a couple of more styles. Another one is Rendered, which will give you a quick clay-like render. And another interesting one is Ghosted, which will also show you the faces and the hidden edges. So see what you would like to work with. I will mostly be working with Shaded throughout the session today. Now, next comes, how do you create any action, or how do you go about working with any commands or tools in Rhino? There are two main methods we will be accessing for today. First method is using the command box on top that I'm annotating in red color. Another method is by using the tools on the left side, which is called as the large tool set. Both of them are capable of giving any kind of tools we want to access for today. And when it comes to large tool set, it is very simple. You have a bunch of icons. Just select on any icon. The command box will start guiding you what that icon is going to do. So if I move my mouse and let us say I choose circle, command box will tell me what or how the circle will work. It will first ask me to specify the center of the circle. I'll connect it here. Then it will ask me for the radius. Just give any number you want the radius to be and press enter. You will have the result. Right? So that is how you go about working with any tools. And apart from that, a few other things you also need to be familiar in the interfaces. First, navigation. Navigation to zoom in and zoom out. You will be using your scroll wheel button. To orbit your screen, you will right click and drag. And to pan your screen, you will hold down to shift. While holding down to shift in your keyboard, you will right click and drag. I will repeat the navigation again in case you haven't got that. Zooming in and zooming out is just using the scroll wheel button. For orbiting, you will right click and drag. And for panning, you will hold down to shift and then right click and drag. So that is how you go about navigating in the software. You also need to make sure your OSnap tools are on. OSnap is available at the bottom. What OSnap is going to do is it is going to help you with being more precise, in the sense when the OSnap is on and you have switched on certain checkboxes at the bottom, it will snap at those different parts of the object. So you can see I'm able to snap on an object with much easier. So this is another tool we would be using extensively today. And when you're using OSnap, some of the default checkboxes I want you guys to have is, one is end, near, then you can have the intersection and perpendicular. These are the four basic OSnapping tools you need to always have on. Another important tool we would be using is something called as Gumbo. What Gumbo is responsible for is, if I select an object, you would be seeing this 3-colored arrow or gizmo. And this is what is called as gumball. If you do not see the gumball at the bottom of your screen, make sure that the gumball is switched on. So you can see I have a gumball at the bottom right here. And if it is highlighted in bold, it does mean that it is switched on. Make sure you mandatorily have the gumball switched on while you're working. And before we continue, guys, just a small thing. The mics are possible to be unmuted. Like we normally just mute everybody's mic, but you can unmute it. Unmute it only if you have certain questions. So what we will be doing is, I will be teaching you some part and you can feel free to work along with me. It will be going in a slow pace. So when you're working along with me, you have any questions, you type out in the chat. If not, what you can do is, after each workflow that we will be having, we have a small 5 to 10 minutes break where we can have a one-on-one session. So during that time, feel free to unmute yourself. But at this point, while I'm teaching, make sure your mics are always muted, or else it's going to be a bit disturbing for the remaining participants in the webinar. Okay, so coming back to the tool Gumball, you need to have it switched on from the bottom. And if it is switched on, selecting an object will give you a display of the 3-colored arrows. The colors represent different axes in the work environment. Red color represents the x-axis, green represents the y-axis, blue represents the z-axis. Gumball is going to help me do some quick transformation. one of the most common transformation we are going to be working with is moving the object. So you can just click and drag on any arrow. It will move in that respective axis. So if I click and drag, the red arrow moves in the x-axis. I do that in the green arrow, moves in the y-axis. I do that in the blue arrow, moves in the z-axis. Right? So these are some basic tools you need to be familiar with in the interface, and other things we will just be learning as we go ahead. All right. So any questions, anyone until this regarding the interface or something? Okay, so going ahead, let me first show you how to draft a curve, because that is something we will be using to generate an interesting facade surface next. So I'm going to switch to the top viewport. So double clicking on the viewport's name goes back to 4 viewports. Again, moving my mouse to the top viewport and double clicking switches back to the top viewport. So to create a curve, one of the methods I'm going to be using is first creating a line. And Rhino is very similar to AutoCAD in how the commands and the command box works. So if you are someone who's familiar with AutoCAD, then it is going to be quite easy for you guys. So first just type in the line command in the command box and press enter. It will tell you what you need to do next. I need to specify the start of line. I'll just snap in the viewport. And end of line, I want to create a straight line. So I'm going to hold it down to shift. If you hold down to shift in your keyboard, it is going to temporarily activate your ortho mode here. So I'm holding down to shift and giving the endpoint of the line. As soon as I do that, I have the line. Now, when you select the line, you will see some points and arrows being displayed. So I can now start selecting the points displayed on the line separately. These points are called as control points. Why? Because if I select the point and use the gumball to move the position of it, I can control the geometry that I'm getting. Again, if I select this point and move using gumball, you can see that the form is getting slightly manipulated. Now, when I'm doing this with a line, it is having only 2 points, which means the possibility for me to manipulate it is only so much. So what I'm going to do is I'm going to use a new command called as rebuild. When I type rebuild, just look at the command box. It is kind of going to be your best guide to the software. It will tell you what you need to do. So it is now asking me to select the curves I want to rebuild. I'm just going to select this line and press enter. As soon as I do that, it is going to take me to a dialog box. In the dialog box, there are 2 things it will ask me to specify. One is the point count and other is the degree. I'm just going to change the point count. You will see a number represented in this small bracket, which indicates the existing number of points. We know that the existing number of points was 2. We want to increase it. I'm going to give a count of maybe, let's say 5. The degree, again, in the bracket, it is specifying the existing degree. I'm going to retain it as 1. I will show you what degree does in a moment, but for now, let us have it as 1 and hit OK. As soon as I do that, now if I select the line, you can see I have 5 points because I have rebuilded it to 5 points. And if I select any 1 point and change it now, you can use either the gumball arrows or you can even use this grid. This is going to be another thing I will be using quite often to manipulate the form. Right, so you can use either the arrows or the grid. And you can now see that the line is starting to break down into more complex polyline geometry. Again, I'm not happy with this. I actually want to create a very smooth, seamless curve. And to do that, I'm going to once again use the same command rebuild. Command box will once again ask me, what is the curve I want to rebuild? I will select this curve, press enter. I'm okay with the point count. We saw the point count was earlier 5. We will retain it as 5. Degree alone, I am going to change to a new degree, which is equal to 3. And when I hit OK, you can see automatically the curve has become a smooth curve. And now if I start manipulating the control points, it will further develop into a different geometry, but it will make sure that the curve that I'm manipulating is always going to be a smooth curve. So this is one of the ways we will be creating a curve. I will repeat the steps once again. You just need to create a simple line, and you need to rebuild it because a line just has 2 points, making it very limited in terms of manipulating into a curve. So I'm just going to select it, use the command rebuild, increase the point count to how many points you want. Make sure the degree is always 3 if you want to work with a smooth curve. Degree 1 is used if you want to work with a polyline curve. So choose what degree you want to work, either 1 or 3. I'm going to stick to a degree 3 and then hit OK. As soon as I do that, I have 5 points in the curve. Now if I start manipulating the 5 points, I will get a smooth curve out of it, right? So that's it. So that's how you go about creating a curve. Another method we would be seeing in or generally to use for creating a curve is using this tool called as control point curve. So if you go to the large tool set, in the second row, second icon, you will be seeing this control point curve icon. You just need to select that. And if you keep snapping at different points, it will start developing into a curve. Once you're happy with the curve, just press enter. I have something like this. Again, if you feel like, okay, there are certain things I can change in this curve, repeat the same thing, just select the curve. You will be seeing the control points. Pick any control point and edit it using the Gumbo. If you want to select multiple control points simultaneously, press Shift in your keyboard. It's going to help you select multiple points together. To deselect any one point or one geometry, press Control in your keyboard and select it. It will automatically be removed from the selection. Right? So that's how you go about working with curves. Now, let me do one thing. Let me delete all of this. I'm going to create a new set of curves so that I can show you two examples on how you can create organic surfaces as well using these curves we are achieving. Once we create the surface, we will move on to the main exercises for today. So to create the surface, I'm going to create a couple of curves, and guys, you can work along with me. Whenever I'm going to be using a new method, I will just give you a head start so you can just pay attention at that time. But apart from that, I'm going to use the same strategy I showed you right now, once again, to generate a curve. I'm going to create a line, a straight line, and I'm going to rebuild it with maybe 8 points this time. And degree is of course going to be 3. One small thing to keep in mind while you're going to be using rebuild is the option delete input. Make sure it is always switched on. If you don't switch it on, what will happen is you will get multiple copies every time you rebuild. You do not want that. You just need like only one copy. So make sure the delete input is always switched on while using this command and hit OK. Once done, I will have a lot of points. I'm just going to pick up one point and edit it. Also, when you are working with curves, it's better you edit like less number of points. Don't have too many control points or don't edit too many control points. It will, I mean, it's just my preference. Editing less number of points will give you a more seamless result. When I start editing more and more points, it starts to become more wobbly and complex. So when you're working with curves, less is more kind of an approach is what works best. And to create a surface, I need a few more curves. So I'm going to create a copy of this. I haven't shown you this technique yet. To create a copy using Gumbo, what you can do is press Alt in your keyboard. While you're pressing Alt, if you click and drag the arrow of the Gumbo, it is going to give you a copy. So again, while pressing Alt, if I click and drag this arrow in the Gumbo, you can see it is giving me another copy. So basically, if I just hold down to Alt, click and drag, click and drag, click and drag, it's going to give me multiple copies. Right? So this way you can create multiple curves using this technique. Now I'm going to manipulate each of these curves. I'm going to pull it down a little bit. I'm going to pull this a little bit inside, so a little bit down. I think this is fine. Maybe I will bring all of these points a little bit closer. And picking this and a little bit closer. Again, every time you want to select the control points of a curve, make sure the curve is selected. Only when you select the curve, the control point display will start to switch on. So make sure you are selecting the curve in order to be able to access these points. Okay, so now I have a curve. I'm kind of happy with how it has formed. So I'm going to switch to 4 different viewports to see how it looks in a complete 3D view. So just double clicking on the name of the viewport. Also, if you want the object to be zoomed in all the 4 viewports, what you can do is select the curve, type a command called as ZSA in the command box. ZSA is the short form for zoom select all. So it's going to zoom the selected objects in all the viewports. Just type the command, select the objects, press enter. You can see it's zoomed in all 4 viewports. When it is zoomed in all 4 viewports, I kind of realize how the curve is very flat, like it is not very organic yet. Looks smooth in the top viewport, but in perspective, it is quite flat. So what I'm going to do now is I'm going to once again select the curve, select any one control point. I will be using either the front or the perspective viewport to change the Z axis of it. So when we are working in top, we have access only to X and Y, which is why it looks smooth only in plan. Now switching to 4 viewports, I'm going to change the Z-axis height a bit. And as soon as I do that, you can see the curve is starting to get manipulated into something more interesting. And also be a little bit careful when you're moving in the Z-axis. If you move in the X-axis, your plan is going to get disturbed. So unless and until you want to do that, don't do that. Make sure that once your plan is okay, you just need to change the Z-axis. I'm just going to undo the previous step. Another thing, Rhino is similar to a lot of other 3D softwares in certain things like how to undo, how to redo, and all of that. Undo is Control Z, redo is Control Y. Okay. Okay, so I'm going to repeat the same for the other curve. Maybe I'll pick another point and change the height of it. Again, selecting the point in the top viewport, changing the height in the front, while visualizing how it is in the perspective viewport. So once I have changed it, I have something like this. Let us maybe maximize the perspective viewport to visualize how the curve is. And again, if you want to visualize it better, like rather than orbiting around the curve, to do a quick animation of that, I will show you another command in Rhino. It is called as Turntable. Just type Turntable and press enter. It will start revolving your model like this, and it will come with this slider. So this slider will help you control the speed of this turntable's rotation. Also, it will help you control the direction, like whether you want it clockwise or anti-clockwise. All right, and yeah, I think now it looks kind of fine. Maybe a little bit I can manipulate further. So let me do one thing. Let me select this curve. Again, when I'm manipulating, I prefer to work with all 4 viewports. Just going to select these 4 points, slightly change its height, and okay, kind of looks fine. All right, so now that we have curves, I'm going to show you a new command which will help you to generate a surface out of it. The command we are going to use is called as Loft, L-O-F-T. And look at the command box. It is asking me what are the curves I want to loft. I will just select these 3 curves, press enter, hit OK in the dialog box for now. I will show you some variations in a while. I get a result that looks something like this. Right, so that is as easy as that to generate a surface out of in Rhino. I will repeat again. You're going to use the command Loft. Just keep in mind of 2 things when you're using the Loft command. First, Loft will work only if you have minimum 2 curves. I have 3 curves, which means it is better. Like the maximum number of curves doesn't matter. Minimum number of curves alone, you need to ensure there are 2 curves. Other thing that you also need to be keeping in mind is the curves that you are having, make sure they do not intersect. If you intersect the curves, like if the curves are intersecting, it will work, but it's not going to give you as good results as you're expecting. So just make sure you have more than 2 curves, and you also have the curves to not be intersecting. Once these 2 criteria are satisfied, type the command Loft, select the curves 1, 2, and 3, hit enter, hit OK in the dialog box. I have a result like this. Let me do one thing. Let me move this aside and let us create a small variation of the same thing. Again, same command Loft. And while I'm selecting the curves also, if you notice, I'm selecting them in a proper sequence, like 1, 2, 3, from left to right. And once I do that, in the dialog box, you have something called as style. If you click on that, it will give you a drop down where you have some variations like loose, another variation like tight. Basically, it's going to change the cross section of your surface. So when I give loose, the surface is going to be deviated from the curves. If I give straight, it is going to give me straight cross sections on the surface. Tight is going to give you a tight cross section. See what style works best for you. I think I'm going to try an option with loose and hit OK. It looks something like this. Again, if you want to visualize it better, let us do one thing. Let us switch to the Arctic mode. It will give you a quick preview of how the surface is formed. And also, we will run a turntable command to see the form in 360 degrees and see if it is okay or there are some changes we want to work with. Let's maybe reduce the speed a little. And yeah, so that's it. You have an organic surface. And that's how easy it is to do in Rhino. I think we just started like 15 minutes before to be working on the curves and surfaces. And within that span of time, we're able to generate something as interesting as this, right? So do try it out, see what the surfaces you can come up with. I'm going to show you one more variation to it. I think we have a little bit more time. One more variation is when you're doing Loft, you're not able to control the cross section of how the surface is forming. Let us say I want to give a custom cross section for the surface. Cross section in the sense how this curvature is. Let us say I want to give a custom curvature for this. Then what I'm going to do is I'm going to create a copy of these two curves. So again, holding down to Alt while moving using the Gumbo helps me get a copy. And for creating cross sections, I'm just going to use the line command. Just snap the start and ends. Basically create a couple of lines here. It's always better to snap at perpendicular when you're going to be working on cross sections. It will make sure that the cross sections are not kind of twisted or angular. So snapping at perpendicular is a good thing to keep in mind while you're going to be creating cross sections. Now the cross sections are completely straight. I want to make it organic. Same method that we saw before. Selecting the lines. I'm going to rebuild it to increase the number of control points. Let us give maybe 4 points. Switching to degree 3 to be smooth. Also make sure delete input is set to yes so that you don't have unnecessary copies. Everything is set, hit OK. I will have something like this. Now let us switch to 4 viewports so that I can start editing them. Whenever I edit, I prefer to always switch to 4 viewports because it gives you a clear idea of how the edit is happening. If you're just going to be working in a single viewport, you will not be able to visualize that very clearly. So it is always better that you switch to 4 viewports when you want to edit the cross sections. I'm going to select these 2 points and change the height a bit. In perspective itself, so I'm just changing the z-axis of it. Again, selecting this. I'm just going to change the height, or maybe let's make it a slight yes, like profile. And let's repeat that for this one. And we have one more curve. Also, if you want to zoom into an object in a single viewport, just select the object and type ZS enter. There are 2 variations. We saw ZSA enter. ZSA means it's going to zoom the selected object in all the 4 viewports. If you want to select, zoom the selected object in a single viewport, just type ZS and press enter. And finally, when we have here, maybe we'll just have a slight height to it. Okay, so now let me zoom out and show you the curves that I have created. We have 2 curves which we drafted earlier in the plan, and I have added some cross sections in between that is going to define the curvature of the surface. To now create a surface between them, I'm going to be using a new command called the sweep to, because they are now no longer following the conditions of loft. Loft means you need to have minimum 2 curves, which is fine. But when it comes to the intersecting part, you can see the curves are intersecting here. So we won't be using loft. Instead, we'll be using a new command called as sweep to. Just look at the command box for the spelling of the command. It's called as sweep to. It will ask you to select the rail first. Rail is nothing but the longitudinal curves. It generally refers to the curves that is going to define the base profile of the surface or the curvature of the surface. So when it is asking me for the rail, I'm going to be selecting these 2 long curves, the first one and the second one. As soon as I select that, the command box will start asking me the sweep shapes. It's nothing but these 4 cross sections. Just select all the 4 cross sections, hit enter, hit OK in the dialog box. And now if you look at it, I have a surface like this. Let us zoom in. It looks something like this. For better visualization, always switch to a render mode or an Arctic mode. And yeah, so I have a surface that looks something like this. So just with very similar curves, using a couple of different commands, you can see that I'm quickly able to generate 3 different options. So this way you can, come up with some interesting, simple manipulated curves and see what are the options you can play around with, right? So yeah, so that's it for the basic interface of how Rhino works. You might be thinking that in the beginning I was talking about how there are going to be varying parameters and you change the parameters running through an algorithm and stuff, but we haven't seen any of that yet. Why? Because Rhino is not the parametric tool. Rhino is just providing an interface for the parametric engine called as Grasshopper to work within. So we'll first be creating some simple geometries in Rhino. Once you create these geometries, you will take the Grasshopper and start manipulating it to get an interesting form. Right, so that is what we will be seeing next. It's about 10:50 in Indian time. We'll take 5 minutes for you guys to try some kind of an interesting form, and then we will move to the next exercise. Meantime, I will also be sharing a file with you, which is what we'll be using in the next exercise to develop a facade for a residential building. So it's going to be a Rhino file. I will share it across in all the WhatsApp groups. Make sure you have downloaded it and also open the file. We'll continue with the class in another 5 minutes, so by 10:55. Also, if you have any questions, you can feel free to go ahead. I would be available here. The file sent right now is in Rhino 7. I'm using Rhino 6. Can you send it again? Sure, Manoj, just give me a minute. I will inform the admin. They will help you with it. Okay, so let us continue with the session. Let me share my screen. Okay, so this is the file we have shared with you. Those who are having issues with Rhino 6 and Rhino 7, just wait a couple of minutes. Our admin will be sharing the file again in a lower version. Can we get a recording of the sessions later? We are streaming in YouTube. I think the YouTube would be recording it and again uploading a higher version of it. If not, we'll see what we can do from our end. But again, I will just check with the admin for that and confirm you in another hour or so in the session itself regarding the recorded part. Okay, so coming back to the exercise, what we are going to now do is create a surface for the facade. And to do that, I'm going to use very similar strategies to what we have seen. Just to give you a basic idea of how the file layers of this particular Rhino file will work. We haven't seen layers yet. You will be finding it on the right side with a tab like this. If you don't find this tab in your Rhino interface, just type properties in the command box and press enter. It will automatically give this tab for you on the right side, right? So that's only if you don't have it. Since I already have it, it's not going to make much of a difference. Under the properties tab, you will have an option called as layers. It is going to have the icon like a cake slice. Just click on that. And you will see a couple of layers. Layer 6 is what this whole building is in. Then we have a curve layer, which is going to have these curves. And then we have a surface layer. So layers are very similar to AutoCAD in terms of the names, the icons, and the workflow. It's very similar. It's just going to help us keep our model a bit organized. So now what I'm going to do is I'm going to take the curves that we have, which are these two curves. You can also directly take these two curves. And when you're working, if things like this happen, that is, we want to work just with curves, but the model is getting unnecessarily selected. What I'm going to do is I'm just going to lock the layer. So layer 6 is what the model is located in. You can click on the lock icon here. It will automatically make the layer non-editable. So if I try to select it anymore, it's no longer going to be selected. Now that I have the curves, I'm going to create a surface between them using the Loft command. Follows the conditions for Loft. We need minimum 2 curves. We have 2 curves and they are not intersecting. So I'm just going to use the Loft command. Select these 2 curves, hit enter, select OK. I have a surface like this. Now the surface looks very plain. I want to make it a little bit more organic and interesting. So what I'm going to do is I'm going to use more curves for lofting instead of just 2 curves. And also instead of taking the same curve that we have here, I'm going to extract a curve from the surface. This is a method we haven't seen yet. To extract a curve which is located inside the surface, that is to extract the curvature of the surface, you can use this command called as extract iso curve. It will ask you what is the surface you want the iso curve to be extracted from. I will select the surface. As soon as I do that, I will get a curve in one of the direction, which is along the width of the surface. Let us say I want the other direction for the surface. You can just go to the command box. You will see an option called as direction. Just select on that and choose the option B. Existing direction is U. You can see it says U. Just change it to B here. And then if you move your mouse along the surface, you will see a curve is following your mouse pointer. Click wherever you want the curve to be selected. Once you are done, just press enter. I'll repeat again, the command we have used was extract iso curve. You select the surface, pick a point on the surface, you will be getting a curve. Now, I don't need the surface anymore. I'm going to delete it. I just extracted a curve so I can manipulate and get something more interesting. Also, the curve that I have right now is in a different layer. I want this to be assigning the curves layer. So to do that, I am going to go to Properties tab, which is next to this cake icon. You will see a circle icon. Just select that. Under that, you will see layer. Click on the drop down. I want it to be in the curve layer, so just select the curves option. As soon as I do that, I have something like this. Select the curve, switching to 4 viewports. Always when you're editing, it is best to work in the 4 viewports, so you get a complete idea of how the curve is being manipulated. I'm going to pick up this point, pull out on the y-axis in plan, maybe move a little in x, and repeat the same thing for another point here. Again, always less is more. Just edit like a couple of points. Don't edit like too many points and make it too complex. Once that is done, we will have 3 curves now. I'm going to once again do a loft command, selecting the curves 1, 2, and 3. Hit enter. You can choose a different style. I think I will stick to normal itself and hit OK. I have a surface like this. Again, I want to change the layer, so I'm going to select it, going to Properties. Under Layer, I'm going to choose Surface, and I have something like this. Right. All right, so now I think this is fine. I will create another surface for the stairwell here for the facade. So I'm going to create a couple of more lines. Same strategy. I'm going to create lines, rebuild it, move it, and create a surface. Just you can work along with me. There aren't going to be much new strategies for creating the surface here. So to do that, I'm going to use a line command. And I'm going to create a perfectly vertical line starting from here and going until here. Now, to make sure the curve is perfectly vertical, this is actually a little bit tricky in Rhino. When you're creating a line in perspective, it will look like it's a vertical curve. But if I orbit the screen, you will see it's actually not vertical. It was just giving me the illusion of being vertical. So this is something that will happen in perspective. You cannot easily create vertical curves. To make sure the curve you're creating is going to be perfectly vertical, one method is to be using the O-snap tools. That is, when you're creating the line, the starting point, I'm going to perfectly snap at this end, and the end point, I'm also going to perfectly snap at the top end of the surface. So when I do that, I can be 100% sure that the line I have got is perfectly vertical. This is one method. Another method you can do to ensure that your line is perfectly vertical, use a line command. And inside the line command, you will see an option called as vertical. Just select that. And then when you create a line, you can see that the line is always snapping to vertical. You're not able to create anything apart from a line in the z-axis. So you can choose any one of these two methods to make sure that the line you're creating is perfectly vertical. I'm just going to delete it. I'm going to create a couple of copies of this because for Loft, we need at least 2 curves. And to make sure the copies are equally spaced, I'm going to create a reference line from here to here. And I'm going to divide this reference line using a divide command. Divide command is the same as in AutoCAD. It will divide a line segment into smaller segments. So I'm just going to type the divide command. It will ask me how many segments I want to divide this line into. Let's get maybe 4 segments. So it will give me some points wherever the equal distribution of the 4 segment ends. I'm just going to use a copy command to create multiple copies of the curve. Again, the command is copy, very similar to AutoCAD. You will give a base point for the curve and a target point. To make sure it perfectly snaps on top of a point, just switch on the point O snap at the bottom. If not, the chances of snapping perfectly on the point is less. So I'm just going to snap, snap, snap. Once I have snapped everything, I will select these curves and points. I don't need it anymore. And also the curves I have created copies for to generate an organic surface. I'm going to put it in the curves layer. So going to properties, the drop down icon and choosing curves. Now that I have this, we know that these are lines, which means there are only 2 points. We want more control points to make it organic. Selecting all the curves, typing the command rebuild. And point count, I'm going to stick to 5. Degree, I think 3 is necessary to make it organic. Hit OK. And let it start selecting the curves one by one. I'm not going to edit all the curves. I'm just going to edit a few curves. Again, whenever I want to edit, switching to 4 viewports, just select and do a ZS enter, just so that the curves are perfectly visible in all the 4 viewports. The command is ZSA this time because you want it visible in all the 4 viewports, and press enter. I have something like this. All right, I'm selecting this curve, picking up one of the control points. I'll maybe move it out a little bit. I'm working in the right viewport now. It gives me an idea of how much it is actually moving out. Also, guys, if you want to work with units, like let us say you want a specific amount of distance to be moved outside, instead of clicking and dragging the arrows, you can just give a single click to the arrow. It will open up a small dialog box where you can give the distance. So let's say I give 1 and press enter. It's going to move for 1 unit like that. So it actually will move in the direction of the arrow. So direction is pointing rightward in the x-axis. So when I say 1, it's going to move 1 unit in the right side. I want it in the negative left side. Just press -1 or type -1 and press enter. You will get something like this. So, and I'm not going to stick to units. I'm just going to move it freeform to see how the form is coming first. And I'm going to pick up another curve, select this point, move it a bit outside. Once I have these two, maybe I'll pull it a little bit closer. Okay, once I have the points edited, I'm just going to create a surface again using the same command Loft, selecting curves 1, 2, 3, 4, and 5. Hit enter. I get a surface out of it. Hit OK. I have something like this. I haven't mentioned one thing regarding Loft. Loft is very sensitive to how the curve is being selected. So when I select the curve in proper sequence, like left to right or right to left, I will get a surface like this. Instead of that, if I do a Loft, where I jumble the selection, that is the first curve, the second curve in the middle, third curve in the corner, then fourth and fifth. Basically, I kind of mix and match the order of selection. It is going to give me a weird surface. You can see these kind of weird overlaps and things happening. So you do not want that to happen. Make sure that the sequence of selection is properly specified. Type the command Loft, select 1, 2, 3, 4, and 5, hit enter, choose your preferred style. I'm going to stick to normal and hit OK. I have a surface like this. Again, switching the layers to surface. So that is pretty much about it. So now what we're going to do is we're going to take these surfaces to Grasshopper and manipulate it to come up with a facade pattern. But maybe I will show you some strategies in Rhino itself, like what you can do. Let me hide the layer of curves. So before we start with Grasshopper, we still have some more time in learning Rhino. So I will show you this one interesting technique called as contour in Rhino. And to take a contour, just type in the command contour. Look at the command box. It's a new command, guys. So if you're working, just pay attention for a minute. It will ask you the object to contour. I'm going to select the surface, hit enter. It will ask me what is the base point of contour. You can give any one corner as the base point. Then it will ask me a perpendicular direction for contouring. I'm going to give the direction along x-axis for now. I will explain you how that works, but for now, just give along the x-axis. And it will ask me one last thing, which is the distance between contour. I'm going to give a small number like 0.15, hit enter. It's going to give me a bunch of curves as the output. You can see command box is empty. Whenever it is empty, it means the output is ready. So you can see it gives me a bunch of curves. If I move the curves aside, it's going to look something like this. Okay. Now, there are a couple of things I can do to this curve. You can either select all of them and create a surface using pipe. So pipe is a command which will give you a pipe-like surface for all the curves, something like a steel pipe or a plumbing pipe like that. So just type pipe. Radius, I'm going to give something really, really small because the contour was taken at 0.15. 0.15 means the distance between each curve that we have here is set to 0.15. So I need to give a radius something smaller than that. So I'm going to select everything, type the command pipe, give a radius of maybe 0.05 and hit enter. You can see I get something like this. Now if I visualize it in the render mode, you can see this is the detail I have got, right? I'll show you one more technique in which you can make the contour into a surface. So let us do one thing. Let us take another contour so that you get the command a little bit more clear. The command is contour. It will ask you for a base point. Base point, you can give any random corner point on the surface. Then it will ask you the perpendicular direction. Perpendicular direction is basically the opposite of the direction you want the contour. I'm getting the contour in the z-axis like this. The perpendicular of z can be the x-axis, right? So that is what I'm doing here. I'm giving the perpendicular direction to it. And holding down to shift to make sure I'm getting a straight line in the orthographic direction. Distance between contour would be the distance between each cross section we have got here. I think 0.15 was pretty good. I will retain the same. Once I do that, I have another set of curves. Now, if I move it aside, I can create a surface out of it using a command called as extrude. Just type in this command called as extrude curve. And it will kind of extrude in the wrong direction. If it is not in the direction that you want to extrude, you can just choose the direction option in the command box and give the start point of direction, which will be on the curve. End point of direction, just hold down to shift and give along the direction you want to extrude. I'm going to give along the y-axis I'm giving here. And then you just specify the distance. Distance, let's give maybe 0.3, hit enter. I have something like this. So this is one option of how you can create a surface. Another option that you can do for extruding is actually a shortcut, which is easier since you are a beginner. Just select all of this. You know, inside the arrow, you can see a small circle. Just click and drag along that circle. It is automatically going to extrude in that respective direction. And you can see I have the same exact result. Now, if I put it to the render mode, scene contour command with a slight variation. First thing we did was using pipe, gives you something like this. And the second method was using the extrusion. So we get some interesting detail like this. Right? So this way you can generate some interesting details in Rhino itself. But again, Rhino is very limited when it comes to these aspects. Grasshopper is much more potential in giving you more interesting outcomes. So let's go ahead with Grasshopper. We have been talking for a while on how parametric strategies are going to make our workflow much easier, giving n number of options. So let us see how to use Grasshopper for that. To open up Grasshopper within the interface of Rhino, you just need to type the command Grasshopper in the command box, right? So just type it as a command. And if you press enter, it will start loading in your system like this. Just wait a couple of seconds. Once it is done, it is going to open up an entirely new interface inside the software. So you will see a smaller dialog box here, just close it off. And this is the new interface of Grasshopper. Let me maximize it so we can have a quick introduction on how the interface of Grasshopper works, and then we will go ahead with the exercise. Okay, so first, open a new document. When you're opening for the first time, you might be having these kind of messy things around. Just go to File, open something called as New Document. Gives you a fresh, clean document. Any previous files or example files that are there will be cleared out. Now, it is going to be a bit different from every software you might have worked with before. Like before, you might have worked with in Rhino, AutoCAD, Revit, SketchUp. All of them are modeling softwares, which means you create a physical model. The Grasshopper interface is going to be a little bit different from that because it is not a modeling software. Instead, it is a platform where you can create algorithms to manipulate the parameters. So when it is going to be something like that, the working space that you are seeing here is called as canvas. So what I'm scribbling right now, it is what is called as canvas. And to create any action inside the canvas, you need to use something called as component to access a component. So component is same like an icon that we saw in the last tool set, or it is similar to a command you would use in any software. Okay, so that is what actually a component is. But to access that component, you need to double click with your left mouse button. It will open something called as enter a search keyword. Type the component name. Let us say I want to create a point. For example, I will type the component name as construct point. It's the name of the component that helps you create a point. Select the component's relevant name here. It will automatically give you a box like this. So unlike the previous softwares where if you type a command, it will ask you certain questions or certain guidance. It's not like that. Whenever you type a component, it's going to come out as a box looking like this. Now, the component has three main parts associated with it. The left part is called as the inputs. The right part is called as the output. And in the center of the component, we have the component name. So we have the inputs on the left, output on the right. In the center, we have the component name. So the parameters that we always specify is going to always come as the inputs. And the component will process it, giving an interesting output. Right? So this is generally the idea of how components work. Now let me show you an example with this component. It is asking me for three things. If I want to create a point, it is asking me to specify what is the X, Y, and the Z coordinate. I need to give numbers for creating that. So let us say I want to create a point 5, 12, 0. I need to create numbers and specify it as the input. To create a number in Grasshopper, same exact method, you will once again double click with your left mouse button and it will open something called as enter a search keyword. Type the number you want. For example, let us say I want a number 5. I'll just type 5. After typing 5, I will press enter. I will get something called as a number slider. So a number slider is exactly what it says. It's a number along with a slider, which means you can change the number to a different number by moving the slider. I will do 2 more times because I need numbers for y and the z coordinate. Y coordinate, the number is going to be 12. So same method, double click, type the number, press enter, you get a number slider. And Z coordinate, again, same thing, double click, type a number, press enter, you get another number slider. Now we have 3 numbers. We need to specify it as X, Y, and Z coordinates. Like right now they are completely independent. I need to give this information to be X, Y, and Z coordinates. So what I'm going to do is I'm going to drag a wire from this component. How I do that is left click with your mouse button and drag. So when you click and drag in this small semicircle, it's going to give you a wire connection like this. Just plug it into the X coordinate here. As soon as you do that, 5 has become the input for X coordinate. How do you re-ensure that? Just move your mouse next to the input name. It will give you a description saying one value has been inherited from a source, which is equal to 5. We'll repeat it again for the remaining 2 coordinates. I want 12 to be the Y coordinate, so drag and plug it in. Again, 1 to be the Z, so drag and plug it in. As soon as I do all the 3 inputs here, look at the final output point. It says one locally defined value, 5, 12, 1. If you want to see it as an output, like when you move your mouse, you can see what is the output. But let us say you don't want that. You want to see it separately. Just connect something called as a panel. Double click, type panel. You will get this yellow icon tool. Just select that. Panel is nothing but a sticky note. Sticky note where if you connect an output, it is going to tell you what is the output coming out of that. Right. So you just again and you see what is happening. So this is the general workflow of how Grasshopper works. Every parameter or every step in the algorithm is defined by certain components. Components is what will help you create different actions. Like you want to construct a point, you want to create a copy, you want to move something, you want to create a surface, like whatever commands we saw in Rhino right now, creating lofts, creating curves, creating rebuilds, etc. All of them are accessible in Grasshopper, but under the name of components. Components, you will give inputs, it will process and give you the output. So that is the general idea of how Grasshopper works. Now, one more thing regarding the components. We saw them only as boxes, which makes it a bit difficult for a beginner to visualize what is actually happening from this component. So what you can do is you can minimize your Grasshopper screen where you have Grasshopper on one side and you also simultaneously see Rhino. When you see Rhino, you can see there is a new X mark annotated in the interface. Like we haven't seen this X mark before. We are just seeing it right now when we open Grasshopper. Selecting the component construct point is going to highlight that X mark. So what this means is whatever I'm doing in Grasshopper through components, it gives me a preview in Rhino, which makes it very, very easy for me to understand what each component is working towards. And if I change the number slider, you can see automatically the value of X coordinate is changing and the point is moving along the X axis. I do that for Y coordinate, you can see point is moving along Y axis. And I do that for Z coordinate, it's only 0 and 1 here. If you want to increase the limit of the slider, you can edit the slider as well. Just double click on the gray portion of the slider, takes you to a sliders editor. Minimum and maximum is 0 and 1. Let's increase it to 0 and 50. And hit OK. Now changing the number slider, it will go from 0 to 50. And you can see the point is moving in the Z coordinate. Right? So this is how the interface of Grasshopper works, and also how Rhino is going to support for any algorithm you are going to be working in Grasshopper. So any questions you have until this? Anything you're not clear with, or you have some doubts related to what we have seen till now, you can feel free to put it out in the Zoom chat. It's clear so far. Okay, that's great. So yeah, so guys, again, if you are a complete beginner to Grasshopper, then maybe if you find this going a bit fast, because Grasshopper is something, so we normally have 11 new workshops in our studio, and Grasshopper is something we will be covering on the 4th day. We're kind of like just 1 hour started with the software. So it might be a bit too heavy if you are a complete beginner. If you feel that way, it's not necessary to work along with me. Just sit back and understand the whole idea and approach, because the whole point of the webinar is to introduce you to what are the possibilities in parametric design and architecture. But again, if you are kind of having a basic idea or you're someone who can grasp very quickly, then definitely work along with us, because we will be getting some final outcomes through the exercises we are doing right now, which you can, of course, use in the design strategies in your college projects or your real-time on-site projects as well. Okay, so let us delete this. This is not what we want. What I want to do is, I want to create an interesting facade pattern on top of the surfaces we have created right now. And what I have in mind is similar to the Tulum's railway station. So let me just share the Tulum's station example we saw in the presentation. So you can see that it has this kind of a pattern which is opening and closing with some panel detail on top of it. So this is what I want to create right now for the surfaces we have generated. So to do that, first step, the surface I have in Rhino has to be imported in Grasshopper. Why? Because they do not, like, you cannot edit a Rhino geometry in Grasshopper unless and until you import it. They are just visual preview interface. You don't have the capability of directly editing it unless you import it. So to import the surface, I'm going to use a surface component. Again, to access a component, just double click on the canvas, type surface. You will see a component that is annotated in black colored hexagon. Select that. Now to import it, what you will do is you will select the component, right click the component. You will see an option called as set one surface. Select that. As soon as you do that, it's going to maximize your Rhino's interface, because now you need to select the surface you want to import. Let us select the surface. As soon as I do that, you can see when I select the component, the surface is being highlighted, which means the import has successfully happened. I will repeat again, if you're working along with me, you basically use a component called as surface, choose the one by black hexagon, right click, set one surface, takes you to Rhino, select the surface in Rhino, you have it imported. Now that we have the surface, we want to create some panels on top of it. To create panels, I'm going to be using the plugin called as Lunchbox. If you haven't installed it, install it maybe in the next 10 minutes break practice session we will be having. So that is the plugin that is going to help us divide a surface into individual panels. Once you have the plugin installed, you will see it under the components tab here. So the param, math, set, vector, all these different icons which is displayed on top. These tools are called as the components tab, or that level is called as components tab. Under that, you will see Lunchbox. You would see it only if the plugin is installed. Under Lunchbox, you will have something called as panels. Just click on the drop down for that. You will see a lot of different varieties of panels here. You can choose any panels of your choice. Since I'm trying to mimic the Tulum's station, I'm going to go for a triangular panel here. I'm just going to choose triangular panel B. It will ask me for 3 things. What is the surface I want to divide into panels? I will say this is the surface I want to divide into panels. And you know that to confirm that this is the input information going into the component, we just make a Y connection. As soon as I do that, look at what's happening. It is giving me into panels. Now, one more thing you can do to make your previews look cleaner is, right now I have a surface in Rhino, which is being overlapped by this imported surface component, again overlapped by the panels. So the preview I'm having is extremely messy in my screen. So what I'm going to do is, I'm going to select the surface in Rhino and hide it off. To hide an object in Rhino, you select the object, type the command hide. in the command box. As soon as you do that, the surface gets hidden in Rhino. Again, if you want to bring back the surface, you can use the command called as show. Look at the command box for spelling. It will bring back the hidden object. This is how you hide and unhide in the Rhino software, like whatever Rhino objects are there. So I'm just going to select it and hide it again. When it comes to Grasshopper interface, hiding is a bit different. You will select the component. When you click on the center scroll button, it will give you a list of icons or tools that you can do here. So when I select and click on the center scroll, I can choose this guy with a bald head. It means disable preview. Just select that option. As soon as I do that, the overlapping surface is also hidden, right? So just make sure you have unnecessary previews always hidden. Not supporting for Mac, can you show how to install plugin? Okay, we will do one thing. We just have one small exercise to try out. It would take like 10-15 minutes. During the one-on-one session, I will show you a few ways of installing this plugin. So if anyone having difficulty, I will just go through that method. Okay, so we have the panels. You can see that the panel subdivision is very much broken down, like it is not retaining the curvature of the surface. When I look at it in the side profile, you can further tell it. So what I'm going to do is we have two more inputs, which is U and V divisions. U and V divisions is nothing but the number of panels I want along the length and the width of the surface. A lot of components come with a default value. So even if I don't specify any U and V divisions, you can see that when I move my mouse, it gives a description saying that one locally defined value of 10 is taken as the default. And for V also, it has a default value of 10. So they do come up with some default options. To change that, we know what to do. We just create a number and give it as the input. Let us give 25, plug it in here. Another number, let's give 25, plug it in here. You can see it becomes more intricate. So if I increase it, and now take a look at the result, it becomes more seamless, right? So see what number works best for you. I'm just going to give a smaller number to start with, because if you give a lot of numbers, too many panels will be there, and sometimes your system might hang a bit. So it's always safer to stick with a little bit less number of values here. So yeah, so that's it. We have a surface divided into panels. Once we have divided into panels, next what we want to do is we want to create the pattern for tooling station. And the pattern of tooling station, it has these kind of openings in the panels. So there are small fenestrations in it. Let me first show you the working logic of how the algorithm needs to be when you want to create the openings. Once we understand the working logic, then we will start connecting multiple components to generate the output. Let me first create a small polygon in Rhino. Why I'm taking Rhino is just so that I can explain the logic of how to create an opening. As we understand it, we will start with Grasshopper. So to create a triangle, I'm using this polygon icon from the large tool set. Normally, when you create a polygon, it's going to come with some default number of sides. I want a triangle, which means there has to be 3 sides. I'm going to go the number of sides in the command box, change it to 3. And as soon as I change to 3, basically this number of sides in the command box needs to be changed to the number of segments or sides you want in the polygon. And as soon as I do that, you can see I'm getting a triangle like this. Now assume that the triangle I have here is going to be these panels. So whatever I'm going to do to the triangle is what I'm going to later do in Grasshopper for each of the panel you see. So to create an opening, first what I will do is I will scale the triangles inward. And after scaling the triangles inward, I will create a surface between the inner triangle and the outer triangle. And we know how to create the surface. We have 2 curves which is not intersecting. So we will be using the command Loft, selecting the inner and the outer curve, hit enter, enter. Okay, in the dialog box, I have a surface out of it. I will repeat again. It's just 2 steps in the algorithm. Step 1 is scaling the triangles to a smaller size inward like this. So this smaller scale geometry will depict the size of opening. Once we have an outer and inner triangle, we are going to create a surface using Loft by selecting outer and inner, enter, enter, hit OK. I have something like this. So this is exactly what we are going to do for every single panel we are seeing. If you can now, because we can go along with you. Okay, but it would kind of break the flow a little bit. I would just cover it up like in 5 more minutes. Just for now, just understand the logic. We will be having time to practice this again in the break or the installation time. Right? Okay, so undo it. Yeah. So this is what we are going to be doing for each of the surfaces. So first I need to scale it in. So step one is to scale in. To scale, I am going to use a component called as scale. Just select that. It will ask me what is the geometry to scale. I want to scale all the panels so that I have a smaller opening inside every single panel. So I will say that all the panel needs to be the geometry to scale. As soon as I do that, there will be some default inputs that is kicking in. So even without me specifying things like center and factor, if I zoom out my Rhino screen, you can see that scaling happens towards the origin here, something like this. So we don't want that to happen. So how or what is actually happening is if I give a scale factor, it becomes more clear. Default is 0.5. Let me connect it. If the scale factor is 1, it's going to be the same size. Okay, so the panels are going to be the same size. As I keep reducing the scaling factor, it starts reducing to a smaller size while going towards the origin. So it starts to move towards the origin like this. I don't want that to happen. I want it to be scaled within itself so that it mimics more like an opening. So what I'm going to do is I'm going to find the center of the panels, use it as a reference to scale it inward. To find the centers, I'm using a new component called as area. It will ask me for what geometry I want to find the centers. I would say for the panels, let's plug it in. As soon as I do that, you can see it is giving me some centroids. I'll connect the centroids as the center of scale. As soon as I do that, you can now see if I zoom out, there is no longer a scale geometry outwards. Instead, when I select it, it is scaling within the panels itself because now it is using the center as a reference. And reducing the scaling factor will scale the panels inside it. Okay, make sure the factor is anything less than 1. If it is more than 1, it's going to scale inside the panels. It's going to be bigger than the panels. We don't want that. We just want it to be like an opening. So give a smaller factor less than 1. And that's it. So we're done with the second step. We have the panels. We have the scale panels. All that is left to do is, so these 2 steps are done. All that's left to do is create a surface using Loft. If you want to create a surface using Loft only between 2 curves in Grasshopper, you can use this component called as rule surface. Rule surface is the same as Loft, just that Loft can loft between multiple curves. Rule surface is restricted to between only 2 curves. We have only 2 curves here, so it is better to use a rule surface. The curves between which we want to loft is the outer and the inner curves. Outer curve is nothing but the panels. Inner curve is nothing but the scale geometry. So that is what I am going to do. I'm going to give this panel as the first curve and the scale geometry as the second curve. As soon as I do that, I actually have the output ready right now. If I select this rule surface, you can see only the surface between the inner curves and the outer curves are formed. But I don't see it yet. Like if I zoom out, I don't see the output clearly yet. Why? Because there is so many unnecessary previews. So when you are working with Grasshopper, always hide everything except the final output because you will see multiple overlapping geometries, which can be very disturbing. So hide everything, select the components, center tool, choose the guy with the blindfolded icon, and that's it. It goes away. Now you can play around with the size of opening. You can see I have something like this. So this is one parameter in the Grasshopper script we have, which is the size of opening. Another parameter that we have is the UNV divisions, that is the number of panels. You can also change that now, like increase it or reduce it, and see what is the panel division that will work best for you. Right? So that's it. So that's the kind of advantage with Grasshopper. Any parameter you're setting, you just need to work on this simple algorithm and you can change the parameters at any given point of time to manipulate it. There is a couple of other things also you can do. So there are only 3 parameters here. But there's one more thing. Let us say I create the pattern. I don't feel happy with the panels I have chosen. I feel like instead of triangles, if I had rectangular openings, it would be more interesting. You can easily change that. Under Lunchbox, just choose a different panel system. So go to panels. We have a quad panel system. I will just pick that up. I will give the surface again as a surface, and it will ask me the number of divisions or number of panels in the U and V direction. Let's give maybe again 25. It doesn't matter, to be honest. You can always change it at any point of time. So just randomly give any division, and once we see the output, we can change it. Okay, so once we give the panels, you can see there are some quad panels. Now what I'm going to do is, instead of applying this entire algorithm to the triangular panels, I'm just going to shift it to the quad panels, something like this. And again, hide the unnecessary preview. You can see I automatically get a result like this. Maybe I'll reduce this and increase this. Gives me a pattern like this. Again, I changed my mind. Let's say I'm not happy with the quad also. I want to try with a different panel system here. Maybe let's say skewed quads. I'll just connect it. Again, the surface. Again, give any U and V division. Let's give maybe 14 by 29 again. And I kind of, reconnect this entire thing here and hide this one. I again get a different pattern here, right? So it is that easy for you guys to be, coming up with different options. And also, if you have someone who has done your internship or you are doing a professional practice, you know that you never give a client just a single option. You give multiple options so the client can choose from what he wants amongst those different options. And we would be spending a lot of time trying to create multiple models to give different options to the client, but it takes a lot of time. Like, so you can, use these strategies to quickly change a couple of parameters, which would take hardly 5 to 10 seconds. And you have a lot of different outputs and outcomes to show to the client. So, yeah, so that's kind of the advantage of how this works. So let me do one thing. Let me just switch it back to triangles itself. Let's delete all of this. And let me also do one thing. I want to apply the same thing for the other surface. So what I'm going to do is create a copy of this entire script. Just select everything, Control C, Control V. Make sure you're in the Grasshopper's interface, press Control C and Control V. It will give you a copy. Now for the copy, what I'm going to do is, I just want to change the surface. Instead of this surface, I want to work on this surface. So go to the component where we have imported the surface, right click, choose set one surface. Automatically the new surface is selected. Let's hide the surface in Rhino to avoid overlaps and play with the UNV divisions to give the panel which would be more suited for this form. And that is it. We have a result that looks something like this, as simple as that. And also, if you want to visualize it better, what you can do is, let's go to the render mode. It won't look good. It will kind of look like a ghosted preview, like the color will look a bit dark. There is another component that is just for visualization. It is called as custom preview. If you connect a geometry, so which is this one, and you can add a custom color preview to that. So material, let us specify using another component called as color swatch. It's just a color picker. It will look something like this, connected here. And to see a better preview, again, hide the previous component. You can see it shows me in that specific color. So I can just change it to a slightly different color, hit accept, and it's going to look something like this. Also, I'm considering the insides to be like open right now. If you don't want it to be open, let's say you want like some kind of glass inside it, the scale geometry already has an inner surface. You can just create another custom preview for that and just change the color of it to maybe a bluish tone and hit accept. And again, hide unnecessary previews. It's going to look something like this. Okay. So yeah, so that's about how we use this algorithm. Let me switch back to the shaded mode and let me move this aside. So we will take 5 to 10 minutes. No, maybe we'll take 10 minutes. It's about 11:41. Let's take till 11:50 for you guys to try this out. Meantime, I will run through the installation of the Lunchbox component. And also I will go through the questions in the chat. So any questions you have, feel free to post it here. So we'll take 10 minutes for you guys to try out the exercise that we just saw. In the meantime, regarding the installation of Lunchbox, normally how you install is if you're using Windows, you will get it as an installation file. Double click on the installation file, it should automatically get installed. So that is how you normally install Lunchbox. This is a method Windows users can be using. Now, let us say if you are not a Windows user, you are a Mac user, then you need to be installing a different version. So let me just show you what version that would be. Okay, so when you go to the link that we have shared, there will be a lot of different versions. Windows users can download the topmost version. If you are a Mac user, use a version that says .zip. So the downloading file would be a zip file and it will not be an installation file. So just download this version. Once you have downloaded it, it will be a zip folder. First, extract it into a normal folder. Contents in a zip folder will not be read by the software and installed properly. So the first step is you always download the zip folder and extract it to a normal folder. Once you have done that, let me show the entire screen so you can kind of correlate. Once you have done that, you will extract it and get something like this. There'll be a lot of different components here. All you need to do is copy this entire file, like it completely, and then you go to Grasshopper. Under Grasshopper, you will paste this into locations. File, special folder, components folder. You will paste it here. You can see I have Lunchbox. Similarly, you will once again go to File, Special Folder, User Object Folders, and paste it here. That is it. So that is how you go about installing. This is if you're using Mac, or even if the Windows version, when you double click and it is not getting installed, you can use this method also. This is even for Windows user, you can use this method. I will repeat again. You will download the mentioned version I have annotated in the Google screen here, which is the zip folders version. Comes as a zip file, you will extract it into a normal folder. After extracting into a normal folder, you will be copy pasting it into locations. File, special folder, components folder, again in the user object folder. So you'll paste it in both of these locations. That's it. So that's how you go about installing the plugin. And regarding the second question in the chat, can you please show how to connect all the parameters to a new one? It's a small hotkey I use. So if I have a new panel, I want all these wire connections to be moved here. Press Shift and Control in your keyboard. When you press Shift and Control, it will get disconnected entirely and you can kind of connect it anywhere. So to do this, you need to make sure Shift and Control in your keyboard is pressed down. All right, I'll do one thing. I will have my screen on. So for you guys to try out, you will have the Grasshopper script in front of you. So if you haven't tried it out yet, you can just use the script I have, use the components as a reference and try it out. How have you installed? This is answering the question from HP in the chat. I installed the Lunchbox, but it is not showing. How did you install? Did you use the copy paste method or did you use the double click method to install? Double click. Okay, whatever method, close Rhino Grasshopper, open a completely new Rhino file and open a new Grasshopper document inside that. You should be seeing this on top. So if it was installed while it was open, it might not have read yet. You need to open a new file for it to load the plugin. Now I see. Thank you. You're welcome. How to install Openness? It is a very similar method. You will download the plugin as a zip folder. You will copy paste it in the two locations that I just showed you. Apart from copy pasting, you will do one additional step, which is go to the components folder again and open the Openness. There will actually be 3 files. This is not necessary. There'll be 3 files. You select one file at a time, right click, go to its properties. Under the properties, you will see an option called as unblock. Make sure the unblock is switched on and hit OK. That's it. So you will see this unblock option only if the installation is not clear. And once you hit OK, repeat the same process for the remaining 2 files as well. You need to be careful here to select only one file at a time. If you select all the files and go to its properties, it will not show you the actual properties we are looking for. So you need to make sure you're selecting one file at a time and then going to its properties and choosing the unblock feature of it. That's it. Once it is done, close Rhino, close Grasshopper, open a completely new document. And how Openness gets installed is not as a components tab. Instead, under the params tab, you will see an Openness pop-up underneath it. It has less components, so it just gets inside an existing tab itself. Thanks. Welcome. Okay, so let us continue with the session. So we're done with coming up for a pattern. Let me delete this visualization. We're going to do some changes to this output we have created. Again, to switch on the preview of a component, select the component, center scroll, choose the guy with the bald head. It's going to enable the preview. Another small clue whether a component preview is on or off is, if you see the component in gray color, it means the preview is off. If you see it in white color, it means the preview is on. So if you're not sure like why certain things are not being displayed, you can use this color code as a small identification to see whether it is in a hidden mode or in a preview on mode. Okay, so now what we are going to do is we're going to develop this algorithm by adding one more interesting factor. The factor is right now the scaling is done to the same size, which means the size of all openings is going to be exactly the same, which is actually a bit boring. Like if you look at the example of the Tulum railway station, you can see that the size of opening was different at different places. They had done it with the logic of understanding the environmental factors and then changing the size of the fenestrations. But what we are going to do is we're going to use a different strategy. We're going to create a pattern using the attractor logic. Attractor logic is something quite common in Grasshopper. It is an algorithm that is used to generate different facade patterns and strategies. So I will show you how it is going to look in 2D first, so that you can kind of compare and understand what we would be doing next. So this is how the attractor pattern will look in 2D. It's not the same exact example. This is just for you to understand how the pattern would work. The logic is simple. You introduce a point which will control the size of the objects around it. Okay, so this is what the attractor pattern is going to do. We are going to introduce a point, use the point to control the size of the panels in our Grasshopper algorithm. So let us switch back to Grasshopper. I need to first introduce a point. Let me minimize Grasshopper. I will create a point in Rhino itself. To create a point in Rhino, use this tool called as single point, which is this one. It will ask you for the location of the point. Just snap where you want. I'm going to snap here. Once I have it here, let me switch to 4 viewports so I can position it exactly where I want. Okay, so let us say I want the point here. Now what I'm going to do next is I'm going to use this point in Grasshopper's algorithm to change the size of the opening. So I need to first import the point. The point I have right now is in Rhino. I need to import a point from Rhino to Grasshopper. So to do that, I'm going to use a point component. It will be denoted by a black hexagon. Right click it, choose the option set one point. It will automatically import the point from Rhino to Grasshopper. Right? That's it. It's the same method as how we imported the surface. The only difference is the component name is different. I will repeat again in case you haven't catched it. Component is called as point. Right click, set one point and select the point. That's it. Now, once we have the point here, next what we are going to do is we need to somehow figure out a way where this point is going to influence the scaling factor, because we know that scaling factor is controlling the opening size, and we want this point to control the size of the opening by changing the scale factor. So what we are going to do is we are going to introduce a new logic. And again, guys, I'm repeating again. So if you are a complete beginner, it might feel a little bit too overwhelming, because as I said, it is not a topic that you start right away when you are just familiar with the software for 1 hour. It's better that you get a good hang of Rhino and then start it. So that's how we normally work with in a long-term workshop. But since it's just a webinar, just sit back, relax, and see if you're able to understand the logic. Learning the components is not a big deal. Once the live stream ends, it would be processed by YouTube, and I think you will get a recorded version directly from YouTube itself. So you can always watch through the recordings and create the copy paste the components that I'm showing you. But understanding the logic is the key. Like only when you develop the parametric thinking and understand how to break an algorithm, that is when you will actually be able to understand the software. So as a beginner, if you're not able to follow through, it's fine. Just make sure you're able to perceive the logics that we are talking about. So coming back, what we are trying is we have a point. We want to control the size of the openings with respect to the point. And to do that, what I'm going to do is the objects which are closest to the point is going to have a small size. Objects which are farthest from the point is going to have a big size. So this is what we are going to do. We are going to analyze whether the objects are close or far, which we will find by getting their distances. Once we understand the distance, if the distance is small, size is small, distance is big, size is big. So to find the distance, I'm going to use a component called as distance itself. It will ask me to specify the 2 points between which I want to find the distance. So it's asking me point A and point B. It will compute the distance between the 2 points. I want to find the distance between the attractor and all the triangular panels here. Okay, so only when I find the distance between the attractor and all the triangle panels, I can see if it is close and assign a small factor, or I can see if it is big and assign a bigger factor. So this is what I'm going to be doing right now. To find the distance between the attractor and all the panels, I will give the attractor as point A or point B. You can give any one input. And the other point, you can't connect the panels directly because it is not a point, it is a surface. So I'm going to pick up a point inside the panel, which is the centroid. As soon as I do that, the component has processed the distances, but we don't see it yet. Why? Because it's a number. You don't see numbers preview in Rhino. Rhino only shows the preview of geometries like curves, surface, solid. Any geometry you have, it will show the preview. But if it's a number, it doesn't show the preview. So not an issue. You can always create a panel. And you get the sticky note, connect the output. It will help you visualize what is the output here. Now I have got the distances from the center to each of the panel. I'm going to use this distance directly as a scale factor because remember, we want to analyze the distance. If the distance is smaller, we want a smaller opening. Distance is bigger, we want a bigger opening. So I'm going to directly plug it in as a factor. As soon as I do that, I actually haven't got the result I was expecting. You can see it is giving me a very weird result. Like in some areas, it has worked fine. You can see that openings close to the point is small. As it goes farther away, it's going big. But as it goes much farther away, that is to the bottom, it's giving me these weird results. Why that is happening is simple. When you look at the output of distances, it is giving me numbers like 2.2, 2.0, 1.7 like that. The numbers are too big. When you want an opening, the scale factor has to be less than 1. Like for example, when I give the number slider of 0.9, you can see it is less than 1. It is creating an opening inside. Any number less than 1 is going to work perfectly fine for creating an opening. If I give any number more than 1, let's say 1.5 and plug it in here, you can see that now it starts to overlap with one another, and increasing the scale factor more and more is starting to give a more distorted image. So what I want to do is, I want to use the distance values, but I also need to ensure of one more parameter, that is the numbers I'm getting from distance should be less than 1. That is, it should be within a limit of 0.1 to 0.9. To achieve that limit, I'm going to use a new component called as Remath Numbers. It will first ask me what are the numbers I want to remap. Remap means basically the numbers I want to change the range for. I want to change for all the numbers from distance. I'll plug it in as a value. Then it will ask me for the source domain. Source domain is nothing but the minimum and maximum of the distance that is here. I can't really find out by moving through the panel. So what I'm going to do is I'm going to use a bounce component. If I connect the distances, it will tell me what is the minimum distance and what is the maximum distance. So this is what it's going to do. Okay. So I'm going to give this as the source. Target is nothing but the minimum and maximum I want. For scaling factor, minimum and maximum can be anywhere between 0.1 to 0.9, 0.1 and 0.9. And when you look at the input, it is actually asking for a domain. It's not asking for numbers. So what I'm going to do is I'm going to use construct domain to make these numbers a domain. So when you're going to give an input, it should say minimum to maximum. You can't just have it as numbers. You connect the numbers directly, it's going to give you a different result. So I'm going to create a domain between them. It will say 0.1 to 0.9. Plug it in as the target. And if you look at the resultant numbers, the same distance is now reduced proportionately between 0.1 to 0.9, something like this, right? So this is what Remath Numbers is going to do. I'll briefly run through again. It is going to take up all the distance numbers as value. It will ask me what is the minimum and maximum distance in the source domain. I find that using the bounds component. And then it will ask me what is the minimum and maximum I want to achieve. I will find that using construct domain and plug it in here. Once this is received, I still don't see any difference in my output. Why? Because scale factor is still empty. So to make sure the size of opening is manipulated by this, I'm going to plug it into the factor. And as soon as I do that, look at what's happening. Openings closest to the point is small. Openings away from the point is big. I think it can be a bit bigger. Don't you think it's too small here? I'm just going to make it 0.25 maybe as the domain start. And plug it in here. And domain end also, I think it's too big. I need to make it 0.8. And yeah, so that's it. That's all you need to do. So it's the same script as before. We just made like a couple of few changes. I will go through the algorithm once again. So this is what we have done. So same steps as before. Before we created panels, we scaled the panels, made sure the scaling was happening within the centers and created a surface. When we just have a simple algorithm, the pattern was a bit boring. It had the same size of openings. So to make it more interesting, what I did was I introduced an attractor point, found the distance between the attractor and all the panels. Once I have found the distance, I realized the numbers were too big because if I give the distance directly as factor, it's giving me weird results. It's because the numbers are too big. So I'm remapping the domain or the range of the distance to have it between 0.25 to 0.8. And the resultant, I'm going to plug it in as a factor. That's it. So that's pretty much how we go about this exercise. Any questions, anyone? Clear. Okay. How about others? Maybe we'll do one thing. We'll take a couple of minutes. It's about 12:05. We'll take like a 5 minutes time for you to try this out again. I'll have the script in front of my screen. And then we will move on to one main exercise, which is till now what we have done. We can change a lot of parameters. We can change the size of the openings. We can change the number of panels. And we can change what panel we're using. So there are so many parameters we can change. But what we can't change here is the surface. Like the surface is very static. Everything else in the script is parametric. So next exercise, we are going to be seeing how you can develop from scratch entirely in Grasshopper. And then finally, whatever we are visualizing in the software, we will see how to create a fabrication data out of it. And so those are the two things we're going to see next. Let me do one more thing. Let me delete these panels for the surface we have done here. And I'm going to apply the same script to this one. So I'm going to create a copy of this. Again, Control-C, Control-V will give you a copy. And I'm just going to change the surface. So I'm going to use show command and right click, set on surface and select the surface. It will apply this pattern on the surface. And also, I want to give a new attractor point. So I'm creating a point in Rhino, changing its position, and importing the point into Grasshopper using right click set on point. That's it. So once I have it, you can start playing with the position of the point and see how it's affecting the point. Okay, so I have the script open for you guys. It's about 12:06. Let us take till 12:10 for you to try this out. and then we will move on to the next part of the session. How can we use multiple attractors? You can do that. So that's actually a good question. What you can do is, let's see for the bigger surface, it's easier to visualize. So there will be like a lot of examples in real time where there are multiple attractors being used. So in that case, I'm just going to create a copy of this point in Rhino. So I have the second attractor. I'm doing by pressing Alt in my keyboard and moving using the Gumbo, something like this. Now what I'll do is I'll repeat the same step again. So I will first import the point using a point component, which would be the next attractor. And once I have the point, I will once again find the distance between this point and all the panels, because I want the attractor to once again change size of the panels. So I'll find again the distance for the panels. Now I have two distances. You can't give multiple distance directly into the algorithm. What you will do is you will find the minimum between the two distances. So rather than connecting the distance directly, you will just have this one new step in between, which is minimum. And you will compare these two distances. The resultant distance will go in this algorithm. So you will give this in all of this. And now you can see there are 2 points affecting the final result. So when you're having multiple points, you basically will have multiple distances between the point and the panels you're trying to manipulate. And what you do is you will find the minimum distance and then use it. Let me do one thing. I think this is the point here. And you can see okay. So, and once it is done, you can see now the pattern is affected by both of the points. For now, you can start off with a single point. Actually, I'm just showing it to you as just a single point. When you are going to be applying it on a practical aspect, you can consider this point to be the position of the sun. So if you consider it to be the position of the sun, then technically the openings closer to the sun is going to be smaller, and the openings that is away from the sun is going to be bigger. So depending on the amount of radiation or the position of the sun at different times during the day, you can start controlling the parameters to be in a more optimized manner. Okay, so let us continue with the session. Let me just stop sharing my screen and reshare it again, because I want to open a new file right now and show you what is the next exercise we're going to be working with. So the next exercise, what we are going to see is, as I mentioned, till now what we have seen in Grasshopper, it has a lot of parameters to change, but the only constraint was that the surface we created is very static. If the surface was also dynamic, then there would have been so many more possibilities in the result we are generating. So that is what we are trying to overcome in this exercise next. And I will show you a turntable of the form we are going to be working with. Right, so switching on turntable. So next what we are going to do is we are going to generate a form entirely in Grasshopper. So what you're seeing here is just an example of a skyscraper where we will just be working on the plan in Rhino or AutoCAD, whichever software you are convenient with. Once you have created the plan, we will take the plan to Grasshopper and generate a tower out of it. Once we generate the tower, we can also add on more details with the Lunchbox handling, just like we saw right now. And to do that, let me put it to shaded and show you how or what are the things we can change as parameters as well. So once you import this curve, so this is the curve I have used as a plan example. Once you import the curve and you switch on the preview, you should be getting an output that looks something like this. Things that we can control is the height of the tower. The next thing we can control is the form of the tower. You can come up with like an entirely different form as well, just by varying this graph. And finally, one more thing we can control is the amount of twist or rotation that is happening. I can concentrate it all towards the top, or I can kind of evenly distribute it throughout the form and basically play around with it until I'm getting the most satisfactory result. Right. So these are the three things I can control in the surface itself. Once I create the surface, I will once again add some more details to it, where one part of it will receive these kind of pattern and the other part of it will just have the surface. So this would be the final outcome we would develop once we have the skyscraper, where we apply the paneling techniques we just saw right now on one part, and another part would just be the surface. Right? So let us start from scratch and let me open a new document. And for the plans, I have actually taken a polygon here as the base curve. So you can just go to Polygon. On the Polygon, you have something called a star. I'm using the star as an example. And giving the center point, the outer radius, I'm just clicking here, and the inner radius, I'm clicking here. Now, if you want more fins in the star, like there are only 3 fins, if you want more than that, just change the number of sides. Box, it's 3. If you give 5, you will get 5 fins for your star. I think I will stick to 3 itself, and I will pull it in 1. Once I have this, I want the corners to be a bit smooth, and to make the corners rounded, we normally use a fillet command in AutoCAD. Same thing here, just use it under a different name. It is called as fillet corners because we want all corners of the polyline to be smooth. So I'm going to use fillet corners. Select the polyline, hit enter. It will ask me what is the radius I want to fillet. Let us give 1.5. Hit enter. I have something like this. That's it. So I just have a simple hypothetical curve used as plan. But again, it is not necessary for you to create it in Rhino. Since you're just starting, you might be comfortable in other softwares like AutoCAD or Revit. You can create a curve in those softwares and just import that curve as plan in Rhino and work on the entire form in Grasshopper. So you can create a workflow which would be more suitable for the softwares you're already familiar with. Okay, now that we have created the plan curve, I'll just take the previous, or maybe let's delete this. So now that we have the plan curve, I'm going to be importing it in Grasshopper. So I'm using a curve component for that. To import a curve, use the component called as curve. It will once again be annotated in black colored hexagon. Just select it, right click and choose set one curve and select the curve. Once you have selected the curve, it will be imported. Same method that we use for importing a surface or a point. Just the component name is different. Method is same, right click, set one curve and select the curve. Now we have the curves. From the curves, we need to figure out a strategy to develop the entire form. Let me explain a little bit in detail as to what were the steps we had in the algorithm to achieve this. So previously what we had done was we had imported this curve. So let me hide this. Yeah. So we had imported this curve as the plan curve. From the plan curve, we will be generating a set of flow plates that's going to look like this. Once we generate the final set of flow plates, we will create a surface using Loft. Okay, so this is what we had done to achieve this. We have a single plan curve. We will be focusing mainly on generating multiple flow plates like this. So first step, we can't straight away get these flow plates. There are going to be intermediate steps to achieve this final result. So first, we will be importing a curve from which we will just get basic set of flow plates. So from one curve, I will be generating multiple flow plates. Once I have multiple flow plates, I will start changing certain parameters of the flow plates. First thing I will change is the size of the flow plates. I will make sure each flow plate is of a different size using the scale component. Second thing I will be doing is rotating the flow plates so that it starts to have like a twist. And this graph that you're seeing here is going to help me with that. So once I do these things, I would kind of get the form I'm expecting. Finally, I will create a surface out of it. So this is the steps I had taken as an approach from single curve to multiple curves, and then start changing the sizes and the rotation of the curve. Once we're happy with the form, use the curves to generate the final surface. So let us do that from scratch. And again, I'm going to be going very slow. So if you're a beginner, just make sure that the logic is clear. That is all that matters when you're learning for the first time in the software. So from the curve, I need to create multiple copies. To create multiple copies, in AutoCAD, we use the array commands. Same thing you have in Grasshopper. I want to create multiple copies along the z-axis. So I'm going to use a component called as linear array. It will ask me what is the geometry I want to array. I want to array all of these curves. So I will connect this as a geometry. Again, just like a lot of components we have seen before, it also has some predefined values to it. So the direction by default is set along x-axis and the count is set to 10 copies. So we don't want both of the default values. We need to change that. Direction I want along the z-axis because I'm focusing on developing a skyscraper-like profile. So to get a direction along z-axis, I'm using a new component called as unit z. You call it as a vector component because it helps you specify a vector in a specific direction. Again, output goes into direction. So we want unit z to be applied. As soon as I do that, look at the result. It moves in z-axis, but it has a predefined height associated between each flow plate. I want a specific height for the flow plate, which would probably be like 3.5 or 4 meters in height. So I want to specify that height between each flow plate or the distance between each copy in the array. You can do so by specifying in the factor. And one more topic we haven't mentioned yet is regarding the units in Grasshopper. Grasshopper does not have a units of its own. It is going to be relied on the units of Rhino. You can see the units of Rhino where I'm annotating. At the bottom left, you will see that my screen says meters, which is the units in which the software is working. So I will be using numbers corresponding to meters because Grasshopper is unitless. It depends on the units from Rhino. I want about like say 4 meters as the height. I'll specify that in factor. Automatically the height will be updated. Okay, so that is how it works. You give a direction as a vector, and to control the distance between each object, you will specify a number in factor. Once that is done, I want more flow plates. We just have 10, which is the default value. I want about, let's say, 65 flow plates. I'll just type 65 and connect it to the count. As soon as I do that, you can see I'm getting multiple flow plates like this. Right, so first step is done. From a single curve, we have created multiple flow plates. Again, it is parametric. So I decide I want the flow height to be higher, I can change it. Lesser, I can change it. Also, I decide the number of flows needs to be lesser, I can reduce it. or more, I can increase it, right? So we can just change these parameters at any point of time. Also, one more small thing in the interface. When you are working, there are going to be a lot of number sliders. And as beginners, if you're going to look at this Grasshopper file after a few days, you will not know what each number slider is saying. So what you can do is you can rename it. Like I can right click the gray portion of the number slider. I will rename it as floor height in here. And for this number slider, it is the total number of floors. I'm just going to rename it to number of floors. All right, so that's it. So next what we are going to do is we have multiple floor plates. We need to start changing the sizes. Only when we start changing the size of each floor plate, we are going to be getting an interesting form like this. To change the size of an object, we know the scale component. I'm going to be using the same thing. I will use a scale component for that. The geometries I want to scale this time is all the floor plates that is coming out of this array component. So this becomes the geometry to scale. As soon as I do that, just like in all the previous examples, the default values will kick in. Center of scaling is the origin. Scaling factor is 0.5. So when I give any number here and start scaling it, it's going to start scaling towards the origin like this. Okay, so we don't want that. We want the floor plates to scale within itself. So just like before, I'm going to find the center of the floor plates using the component area. Geometry I want to find center is the output geometries from linear array. And I will get the centroid, which should be used for scaling. Okay, so default scaling center is origin. It kind of skews my building to a smaller size towards the origin. I don't want that. I want the centroid to be the center of scaling. As soon as I do that, if I zoom in, you can see that the scaling starts to happen within the floor plate, which is perfect. That's exactly what I want. Now what I'm going to do is hide the preview of unnecessary things. You can see it is starting to give me a very confusing previews now. So I'm hiding the preview of previous steps, just having the preview of scale component, because that is what we are working with right now. Now, when I scale it, we have expectations that each floor plate is going to be of a different size. Like when I scale it right now, all of them are scaling to the same factor. It's not interesting at all. Like it's kind of becoming smaller in size. That is not what I want. I want the entire floor plate set, like each floor plate of a different size. So this is where the most crucial part of this algorithm is going to come into play. There are about 66 floor plates. Each floor plate is going to get a different scaling factor. If I add more scaling factors here, like if I add 1.5 and connect it here, you will notice there are two different scaling factors. Like the first curve gets the first number, second curve gets the second number. I add another number, maybe 1.8, and plug it in here. Let's reduce this a bit. You will notice first floor is 0.5, next floor is 1.1, next is 1.8. I create more copies of this and start changing the factor. You will notice that each floor plate starts to receive a different scale factor one by one. But to create 65 number sliders and specify as a factor, it is not possible for me to do that. Like there are so many floor plates, it's going to be very difficult to create so many number sliders. So this is a very bad idea. I'm going to delete it. Instead, I'm going to use a component called as range, which will give me a list of numbers. To do that, I'm using this component called as range. As I said, this is one of the most crucial steps in this algorithm to be getting this varying form. It will once again ask me the domain. Domain refers to minimum and maximum in Grasshopper. And since we're giving for scale factor, I need to specify the minimum and maximum scale factor. Let's get minimum as 0.15 maybe. So the original floor plate is going to be reduced down to a minimum of 15%, the original size. Maximum, I can go up to 1.5. So I can extend up to 1.5 times the original size, okay? So scale factor, the numbers that I want to generate for creating the scale factor can be between 0.5 to 1.5. So this is what should go into domain. Domain will not work with numbers. You connect a number slider directly. The result, the chances are you will get some kind of an error. We don't want any errors. So instead of connecting as a number, we will pass it through as a construct domain component. So it will take these numbers as start and end, and the resultant will be a domain between those two numbers. Give this as the domain. Then it will ask me for steps. Steps is, let's do one thing. Let's connect the panel and see what is the result we're getting first, and then change the steps. So when I say domain 0.15 to 1.5, it gives me a list of numbers between that. It has given me 10 to 11 numbers. That is because the steps is set to a default value of 10. If I give a different number in steps, let's say 25, it's going to give me 25 values. If I say 100, it's going to give me 100 values. So depending on what number I input in steps, I'm going to be getting that many number of values or data as the output. We want the data to be equivalent to the float rate. Before we do that, there is a small catch in this component. It is actually not equal to the steps we're saying. So if I say I want 2 in steps, look at what is happening. It is giving me 3 datas. And if I say I want 3 in steps, it's giving me 4 datas. So basically, no matter what number I specify in steps, the component has a tendency to give one value more than that. To rectify that, what we can do is right-click steps, go to expression, add something called as x minus 1. You're basically saying, don't give me that additional value, subtract one value from whatever outputs you're planning to get. So this is what the expression is. This is just to make sure whatever number slider I give in steps, it's going to be the same when it comes as the output. So right-click, expression, change to x minus 1, commit changes. Adding an expression will also give you a small indication here as a star symbol, which means that expression is set. Okay, so we have a range of numbers. Let us plug it in here. Look at what's happening. When I give 3 numbers, only the first 3 flow plates are having a different size. If I give 10 numbers, oh, okay, it's right now at 100, which shouldn't happen. But let's say if I'm giving 20 or 80 numbers, we can see first 18 flow plates are having different sizes. I want all the 66 flow plates to have different sizes, which means I need to create 66 numbers, which means step has to change. I'm going to plug in from this number slider directly here, because this number slider in count is already giving the number of flow plates in the array component. I'm just going to use this directly so that if I change this number slider, automatically the entire script is going to be updated, just to make sure the control is a bit better. And one more small thing, the form is inverted. I prefer the base to be bigger and the top to be narrow. So I'm just going to flip the domain start and domain end. As soon as I do that, I will have something like this, right? So that's it. There is a few more things I want to add. Like, I'm still not happy with how the scaling is. It looks very bland, kind of like a Christmas tree, like the base is big, the top is narrow. I want to add more interest to this form. So we are going to be using a new component for that. But before that, do you have any questions? Are you guys clear with whatever is taught till now? Yes, ma'am. Okay. Okay, so it is clear. So great. So let us move with the next step, which is making the form more interesting. We don't want it to be so uniform like how we are seeing here. We want to make it more interesting. Yes, Gopi, you can use attractors. So if you're using attractor, same like before, you will have a point and you will find the distance. The distance, if you use it directly as the factor, it might be too big. So you run it through a Remath Numbers to control the minimum maximum number, and you can give it as a scale. So of course you can use an attractor as well to generate varying sizes. But I'm going to be showing you a different strategy here. It's one of my most favorite strategies when you want to generate a form with like a varying shape. And also it is going to respond to some mathematical graphs like sine graph, cos graph, or maybe Bezier graph, things like that. So to do that, I'm going to use a new component called as graph mapper. And it's going to look like a box. It's very different from the components we have seen before. That's because there are like slight differences in how the inputs and outputs work. First, Input should be a list of numbers. I'm going to give all the numbers from range. So input always should be a list of numbers. That's like a mandatory thing for the component. I'm just going to give all of these numbers. And the output would be connected to where the range was initially connected. So basically going to tuck in between the range and factor because range was not doing a good job of giving me an interesting form. So I'm introducing this component tucked in between the range and factor. Then you don't see any difference yet because as I said, there are a few more things we need to change. First, we add a graph mapper, right click, choose graph types. You will see a lot of different graphs. Choose any graph of your preference. We will try a Bezier graph first, and then we will see whether we can go with a different graph. When I introduce it, it looks a bit weird. So what we are going to do is there is one more thing to edit in the graph marker, which is nothing but the domain. So graph also has a domain. It's a 0 to 1. Whereas the range is having a different domain, which is 1.5 to 0.15. So what I need to do is I need to make sure that the domain of the graph mapper and the domain of the range is matching. So to achieve that, double click on the graph mapper, takes you to an editor. X0 value should indicate the domain start, which is 1.5. X1 will indicate the domain end, which is 0.15. Repeat again, Y0 is the domain start, 1.5, and Y1 is the domain end, 0.15. And hit OK. I will have something like this. There is no difference from what we initially saw, but now we have a couple of nodes within the graph, which when changed, we can start seeing that the form is getting a different shape now. And also, if you're not happy with the graph type, you can always right click it, go to graph types and choose a different graph. Let's maybe try a sine graph this time. And when I use a sine graph, you can see it's giving me a varied kind of form here. Right? I'm just trying to mimic the one we have on left. So I'm going to create a form with respect to that, but you can choose any kind of form. I'll repeat again. We are using a graph mapper because the range is very bland. It is not at all giving an interesting form. So we are going to connect it through a graph mapper. For graph mapper to work, you do two things. You will right click and add a graph type, any mathematical graph of your preference. Once you add the graph type, you need to make sure the domain of the graph is going to match perfectly with the domain of the range. If to make sure they are matching, just double click on the graph mapper. You will get an editor. You need to change the settings here. Now we are done with the scaling as well. So there was one more parameter which we did, which is rotating the flow plates. So to rotate the flow plates, I'm going to use a component called as rotate. There'll be a lot of different rotates. Choose the one that says rotate an object in a plane. It is very similar to rotate in AutoCAD. Like you have a base point and it rotates about it. That's exactly what the component does. So go for the rotate option that an object in a plane. The geometry I want to rotate is these flow plates. So this is the updated flow plate I have right now. This would be the geometry. And as always, default values start to kick in. First thing I want you to change is angle in Grasshopper, like any component in Grasshopper, angles are always in radians. I mostly work with degrees. So the first thing I do in the component is right click angles and change it to degrees. So that is the first thing I do. Now, next thing, if I go to the top viewport in Rhino and look at the result, like let me add an angle to it, maybe 150 and connect it here. And if I do the rotation with this angle, look at what is happening with the rotate component. It is making circles or rotations around the origin. That is because the base point of rotate is set to origin. I do not want that. I want the rotation to happen within the flow plates. So what I will do is plane refers to the base point of rotate. I will give the center of the flow plates that we earlier found, which is this one, as the plane of rotation. As soon as I do that, when I'm rotating it, you can see it rotates within the flow plate. Right? So these are the inputs to give. Geometry would be the geometry from scale. Angle, make sure you change it to degrees by right clicking. And for plane, you give the center of the flow plates so that the flow plates rotate within itself. Again, for better preview, make sure you hide everything before, just the final output to see exactly what is it that we are working with. Now we have the curves, but we were looking forward to create a twisted profile. We don't have a twisted profile yet. We have a very flat profile. Why? Because there is only one angle. One angle means all the flow plates rotate to the same angle. If I add another angle, let's say 250 degrees, and plug it in here, you can see the first two flow plates have a different angle. I add a third angle in here, first three flow plates will have a different angle. So basically same as before. If you have one angle, all the flow plates receive the same angle. If you have multiple angles, each flow plate receives a different angle. So to make sure each flow plate is going to have a different angle, the same strategy we used before, I will create a range of numbers and then give it as the angle in here. Can you explain graph number range setting again? Yes, we would be seeing it right now for the next components angle. So we will go through that once again. So I want multiple angles, same strategy using a range and graph mapper. So this time the domain of the range should correspond to the minimum and maximum angle I want. Minimum angle I want is 0. Maximum angle I want is 360. These are numbers. You can't connect the numbers directly. You pass it through a construct domain component. 0 to 360 will be the minimum maximum. Connect it here. Now steps is set to 10, which means it gives me 11 outputs. If I connect it here, only first 11 flow plates are going to be varying. I don't want that. I want every single flow plate to vary. So the total number of values should be equal to how many flow plates are there? There's about 62, which is controlled by this number slider. So just drag it and connect it here. So when you say number of floors, there is only one number slider that controls the number of floors. Every time you change it, it's automatically going to change for every single output here. And when we do that, there is going to be a small problem of some intersections here. Why? Because even when I say 62, 67, or whatever numbers I give, output gives one additional value, giving me a small error. To make sure it is rectified, right-click steps, go to expression, change it to x minus 1 and commit changes. I have something like this. And that's it. So we have a twisted profile. If I don't give a range of angles, has only one single angle, looks very similar to the original one. When you give a range of angles, it's going to have different rotation angles and give you like a twisted profile. If you further want to make it more interesting, like you want to control where the rotation is more and where it is less, you can, of course, add a graph mapper. It's not a necessary step, but it just adds more interest to the script. Always list of inputs would be a list of numbers. Output will be connected to angle. Right click, add a graph type of your preference. I'm going to go for a Bezier graph. Make sure domain of the graph matches the domain of the range, which is 0 to 360. Double click, just change 0 to 360 and 0 to 360 as the minimum and maximum. Hit OK. It gives me the initial form, but this time we have a node which will help us control how to get the final outcome. So once I change it, I will have a final set of curves. I'm happy with the result. I will create a surface out of it using the Loft component. And when I connect it together, that's it. I have a result of the skyscraper surface. So let me quickly run through the process once again, like the basic approach of the algorithm. So in case you have forgotten the flow, we will briefly run through it. Single flow plates to multiple flow plates using an array component. Direction you would give using a unit set vector, which also controls the distance between each flow. And you also give how many floors you want. Once you have the flow plates, we change the size of each flow plate. And to do that, we make sure we are using a range and graph mapper, which is like the most important tool to make this exercise like a form finding exercise or the result we are getting. So I'm using a range along with a graph mapper. Domain corresponds to minimum and maximum scaling factor. Steps corresponds to the total number of numerical values I need to generate. And once scaling is done, next I will rotate the flow plates. Same technique, but this time instead of giving varying factors, I will give in varying angles of rotate. Once I'm happy with the form, just loft it together, you get a surface here. Now, since everything is parametric, what I can do is I can just create a couple of copies of this and show you some variations. So let us say I am creating an ellipse. something like this. And I can just right click, set one curve, select the ellipse this time. I will get a new outcome with the same tower. Scale looks a little too big. Let me just scale it down. To scale using Gumbo, you can use these colored dots. Dots will help you to scale in Gumbo. So I'm just going to scale it by holding down to shift to a factor of 0.5. And I have something like this. Now you can start changing the parameters, like you can start giving a different profile for the graph. Something very more subtle, something like this. And also let's change how the twist is happening. And as soon as I do that, you can see I'm easily developing another skyscraper. Same script. Hardly I took like a minute, but I'm done with the next outcome here. And again, let us say I want a third outcome. Let's do one thing. Let's hide the flow plates preview for this one and the previous one. So let's say I want to get another outcome. You can even try one with a control point curve. It's the freeform curve tool we have used. So you can kind of create any kind of an interesting profile. I'm just modifying the control points a little. And once we have the next curve, another copy of the same script. And importing the next curve inputs, right click, set one curve, select the curve. Again, scale is too big. Let us scale it down to half the size. And once we do that, again, manipulate the form. And once again, manipulate the amount of twist that is happening. And once it is done, I think it's still too big. Let's reduce it further to 0.6. I have something like this. So it's the same exact script. Just by varying the initial curve I'm using, you can see how powerful Grasshopper is to give me so many different options here. And we normally teach this exercise actually in our 10 days workshop. I will show you what are the different outcomes or possible outcomes that the students have kind of experimented with this technique. Just to give an idea, like, furthermore, what are the possibilities you can work with in the same script. Yes. Okay, so some experiments done with the same exact script, there isn't any difference by the students to generate entirely different outcomes. This is done using almost like an hourglass profile. Like if you look at the top, you can tell this hourglass profile. You can kind of guess what is the plan form used. And the tower is generated. Once the tower is generated, the surfaces are divided using the Lunchbox panels with some circular patterns created on top of it. Another example of another interesting experimentation is instead of considering it to be a skyscraper, because the technique is only for form finding, you can apply it in different scales with slight variations to reimagine it to be a different architectural element. Like in this example, it is instead of taking in the z-axis, the form is taken in the x-axis or the horizontal axis, and you're getting an interesting form out of it. You can even reduce the scale and maybe reimagine it something as small as a furniture. Like you can have a cross-section of the furniture, develop remaining cross-sections of the furniture along the horizontal axis, and come up with an interesting example as well. But anyways, so that is how this form was generated. And once you have the surface, it is divided into two parts, one part and another part. So basically it's split into two smaller segments. One segment is retained the same. Segment number two is divided using some Lunchbox panels and then detailed out on top of it. And this is another interesting example where same script, but instead of considering it for a plan curve, the participant has worked with some modular elements like boxes, and those modules are, moved, scaled, and rotated to generate a final form like this. Right? So basically, what I'm trying to say is the possibilities are endless. The script has a very, very good potential on being developed into something more interesting. And also, since the session's recordings are shared, we would be, I think we have mentioned that it's a certified webinar that we're having. So to receive the certificate, you need to be generating some output with the exercises we saw in class today. It's up to you. You can create any kind of output. There is no restriction as to what has to be generated. And you need to just submit it to us via email and also share an Instagram story of it and tag us, and you would be eligible to receive the certificate. I would just go about the details of it in the WhatsApp group, like which email ID, what ID to tag in Instagram, what is the date of submission, all of that. We'll give you a couple of days for that. But yeah, so that's what you would be receiving out of the end of the workshop. So it's about 12:50. I will leave my screen as it is. Meantime, any questions, guys? We are going to go for another slightly longer break, maybe like 15 minutes to have some coffee and refresh ourselves. And then we'll be back to see some fabrication examples of this. Before we do that, I will show you another thing that we teach in class, which I think is very relevant to the initial example we saw. So this is actually something we teach part of our 11-day workshop. This comes almost like in the 6th day of the workshop where we generate a skyscraper, but we take it to the next level, like how we saw the Tulum's example. Similarly, what we will be doing is we will analyze the skyscraper for the amount of radiation. So once the skyscraper is done, I will switch on the surrounding context. We will be analyzing the skyscraper for the amount of radiation. To do that, I'll be teaching a plugin called as Ladybug. And once we analyze the radiation, we will be creating some facade patterns on top. So I will hide this and switch on the facade pattern that we work on. It's the same pattern we saw right now, just to give an idea of how the logic works. So the panels receiving hotter radiation would be having smaller openings, and colder regions will have bigger openings. So this is an exercise we would be covering in class. But since we teach it on a much later date, like the 6th session, by then students will be able to create their own interesting patterns, like any kind of facade patterns that you want to replicate, you would be able to do by then. So we will be showing some more examples of how the patterns that they have worked with can be used and manipulated with the radiation result we're getting. So this is another example where the pattern is different, has something like a star-like pattern, and the panels are bigger again when it's hot, panels are smaller when it is cold, allowing more light and ventilation, right? So these are some things you can, again, just to give you an idea of what is all possible in the software. These are some things you can try and experiment with. And the same strategy is what is used by the initial example of Tulum railway station I had showed in the presentation. A very similar strategy they have used in their design workflow as well. And if you are interested in these kind of things, I think one very good example is the Al Baha Towers that is located in Dubai. They have a facade system which is kinetic. Let me just share my Google screen and show you. So they have a facade system which is kinetic in nature. So basically, to give you a little context about the building example, it is located in Dubai or Abu Dhabi, I'm not sure, but it's located in one of the Middle Eastern countries. And you can imagine the temperature that they have. It's going to be extremely hot. On top of it, they have decided to go with a glass facade for the entire tower. In spite of using glass facade, which is known for the amount of heat it can absorb and make the interior spaces a little less than comfortable for people being inside, they have been able to achieve very comfortable conditions on the interiors. And how they did that was by coming up with a facade pattern, something like this, which is kinetic in nature. So basically what the facade does is, depending on the position of the sun at different times during the day, it will open and close. So if the sun is farther, it will open. And if the sun is closer, it will kind of close and act as a skin protecting the buildings inside. So it's a very interesting example. You can actually, by the time like you go through, you understand the Ladybug plugin and you understand the radiation analysis, you can recreate the same exact example with help of Lunchbox and Ladybug together. Right, so let us do one thing. I'm going to switch on the script that we had worked on right now, which is this one. Yeah, so I will have a preview of the script on in my screen. And it is about 12:52. Let's take a 15 minutes break. Let's take say around till 1:07 in Indian Standard Time. So wherever you're from, just calculate 15 minutes from now. After 15 minutes, we'll be back to see two things. One, how to go about fabricating the data we have worked with right now. And finally, we will also get some more idea on what are the other possibilities with the software that you can work with. Right. Any questions, by the way, before we take a break? If you have any questions, you can go ahead right away. Okay, then, so we'll be back in another 15 minutes and see you guys. Okay, so hi guys, I hope you guys are back from the break. We'll maybe wait for another 1 minute in case someone is not back. It's just 1:07. We'll wait till 1:08 and then we will continue with the session. Meantime, I'll just have my files open and set up. Okay, so we will continue with this exercise. So one thing that we haven't seen yet is how to create patterns on top of it. So same thing, just go back to the previous script, which is in this file. And once we have the script, let's just select the entire script. I'm not going to use an attractor. Okay, let's just copy this. So press Ctrl C in this file and then go back to the other Grasshopper document and press Ctrl V. And as soon as you do that, you can see it gets pasted here, but it gets pasted somewhere else. I'm just going to move it. It will show some errors because we don't have the imported surface or the attractor point. That is fine. I'm going to use this lofted surface as a surface for paneling now. Let us see how the panel is divided. And let me hide the preview of the previous surface. That's when we'll clearly see how it is. You can see it has broken down the geometry a lot. I'm just going to increase the number of panels a little bit. Always remember that, increasing the panels will make your system a bit heavy. So just keep that in mind whenever you're increasing. So don't increase it a lot. Okay, so now that I have this, I don't see the pattern yet because there is no attractor point. Let us give a constant scaling factor first with a number slider, and then we will use an attractor to change the sizes. And hiding unnecessary previews looks something like this. Again, for a better preview, let's add a custom preview component. It will help us add a separate color or material. So I'm just adding a geometry and a color swatch in here. Let's give a slight gray color and hit accept. Looks something like this. Maybe we can even add a glass material for the inner scaled panels that is there. So I will give this as the geometry this time. It's basically the panels on the inside. And I'm going to give a bluish tint to it. You can also reduce the transparency. The A value at the bottom is going to help you reduce the transparency.
Sorry.
Yeah.
If you're doing something on your screen, it's not visible. I don't know whether it's a problem for me or it is for everyone.
Okay. I think, yeah, Ken, there's a few more happening for issues that is there. I think the screen share. Oh, I'm sorry, guys. The screen share was a little messed up. Let's do one thing. I will just delete it, show it to you once again. Now, can you guys see my skyscraper file?
Yes, it's visible now.
Okay, so let me just paste the script that we had copied from the previous facade example for the paneling. And it is automatically going to give you some red and orange colors just because we don't have the initial surface imported. So the surface is not there in this file, which is why it gives the error. Just delete it. Give the result from Loft. Loft gives us a surface. If I switch on the preview of triangle panels, it looks something like this. Again, hide the surface, just have the preview of the panels. You will see it is a bit broken down. Let us increase the number of panel divisions to match the curvature of the surface. And again, we don't see the final output because for scaling factor, we don't have a point attractor. I'm going to give a number slider first, and then we will change the point later. So when I give a number slider and hide this preview, you can see I have a clear output. For a better preview, I'm going to add a custom preview component. if you connect a geometry, it will help you add a specific color by using the component color swatch. We'll plug it in here, give a slight gray color, and hit accept. Similarly, we can add another preview for the scale geometry, which is the inner ones. I'm going to give a blue color. And also reduce the transparency. The A slider in the color swatch will help you reduce the transparency. So you can just reduce it a bit, hit accept, switch it to the rendered mode now. Again, hide the preview of any unnecessary components. I will have something like this, right? Now that we are done with the form and detailing, again, if you want an attractor to be involved in the algorithm, just put it to shaded. We will create a point here, and let's just move it up a bit, maybe somewhere here. Right click, set one point, and instead of a number slider, we will use the attractor's distance value in here. As soon as you do that, look at the size of the openings. It's now being controlled by the attractor, and changing the position of it helps us change the size of the openings. All right, so once we are done with this, so normally when we are working with Grasshopper, there are going to be three phases of a workflow. First phase is where you have your ideas. What are the parameters? What are the design elements you want to work with? Once your ideation is done, next you will start with creating a digital model of that. So that is what we do using either Rhino as a physical model or using Grasshopper, where we run through certain algorithms. Once we are done with visualizing our design digitally, next thing is to get a fabrication data out of it. There are a lot of different methods of how a fabrication data can be generated. So there are going to be steps like rationalization. Rationalization means you have an organic geometry, you break it down into a fabricatable geometry. That is exactly what we had done right now. So the lofted surface that we're having here, it's a very organic geometry. And we are breaking this down into a fabricatable panel. We're adding some patterns and details to the panel. And now what we're going to do is, once we have added these details and visualize the final output, we are going to be placing these panels inside a sheet, which will later then be sent for CNC cutting or laser cutting. So when we want to do that, we will be using the plugin called as Openness. Let me first show you what an Openness outcome will look like. So if you see my Google screen, you can see that when I search for Openness Grasshopper, I have some examples that shows how the outcome of Openness will be. So basically you have a form which is divided into panels. Each of the panels are taken from its position and nested inside a rectangular sheet. Right? So that is how the Openness generally works. When you're using Openness plugin, it's going to do one more thing, which is optimize the number of sheets to its minimum number so that there is least amount of material wastage. So when you're going to be placing, let's say 10 or hundreds of panels, there are different combinations in which the pieces can be nested. You can have a few pieces here, another few pieces here, or you can kind of randomize that combination. So Openness will strategize it and make sure that minimum amount of material is used while nesting inside the pieces. Coming to the questions in chat, what if I want larger openings near the point and away from the, okay, we will see that. And after log, how do we turn that into a surface? I missed that part. Okay. So there are two questions in the chat. I will look into it before we go to the Openness, because Openness will be an entirely different topic. First question is how to change the size of the openings. So I have the attractor here. Opening close to the attractor is small, away from the attractor is big. Let us say you want your design to mimic it the other way around. That is, close to the attractor, it has to be big, and away from the attractor, it has to be small. Then what you can do is flip the domain start and end. Give a bigger number for domain start. This is where you're doing the Remath Numbers. Give a bigger number for domain start and a smaller number for domain end. When I do that and zoom on, you can see openings close to attractor is big, away from attractor is small. So that is answering the question from Shreya. Next, answering the question from Ralu. Excuse me, after Loft, how do we turn into a surface that we can, I missed that part. Okay, so the question is, after lofting it, how do we convert it into a surface for the panels? Ideally, you should be having it as a surface. So when you are lofting it, you can see the output of Loft is giving me a surface. So I'm directly using that Loft into the paneling system. If the resultant of Loft is not a surface, by any chance it is a poly surface, then you will need to explode it. So it's nothing but, I will first show you what that means. If I select it and the property says it's a poly surface, so extrusion or whatever, if it's a poly surface, basically has multiple surfaces. So you will normally explode it, use individual surfaces for paneling. Same thing you need to do in Grasshopper. To explode in Grasshopper, you will use a component called as deconstruct direct. This is only for those who are getting the output of Loft as a poly surface. If it's a poly surface, panel will say it is a direct. So if your output says it is an open direct or closed direct, it means you have a poly surface, and a poly surface will not work in triangular panels. If I have to show it to you, then let's say I'll create a curve and right click, set one curve, select the curve. When I do that and switch on the preview of Loft, it will be a poly surface. You can see it says open direct. When I connect it to panels, it would give me an error saying that, it's a poly surface. Let's maybe reduce the size of it, it's too big. So what you can do to rectify that is explode it using the component deconstruct direct. It will give you the individual surfaces under the faces output. Use that faces as a surface here. And when you do that, my system just hanged because there are too many surfaces. Okay, it came back. Too many surfaces, but now you can see it's being applied for every single panel. So this is what you do if you are working with poly surface. I'm going to switch back to the surface itself. Set one curve, selecting this. And hide the lofted one. If it's a single surface, explode is kind of pointless. It's going to give you just one single output surface. All right. So any other questions, guys, related to this before we move into using openness to extract these panels? Okay. Before we go into openness, I'm just going to reduce the number of UNV divisions because if there are too many panels, then my system will take a little bit more time to process the data and give me the output from openness. So just to make sure that, it's going to be a bit faster, I'm going to reduce the number of panels to 25 and maybe 21. It will give me broken down geometries, but just fine. Just to understand openness, we are doing it. Can you explain the point attraction one last time? I just introduced an attractor point here. Let me select it in Rhino. So I just introduced an attractor point. Find the distance with all the panels. Distance is too big. So I'm using the Remath Numbers to reduce the proportion of it to a minimum and maximum of 0.25 and 0.8. And then giving it as a scale factor because you can't have scale factor more than 1 when you're trying to create openings. So yeah, that's the only step I have used for Attractor. This is answering the question from Vigneshwaran in chat. Okay, welcome. Okay, so let us start with OpenNest. And for OpenNest to work, first step, we can't use the panels directly. We need to put the panels in an XY plane. That is, right now it is at an angular plane or it is at a specific angle. We can't nest it that way. We need to make it flat along the XY plane or in terms of plan. So to make it flat, what I'm going to do is, this is the geometries I want to nest. So to make it flat, I'm going to use a new component called as orient. This is a Grasshopper component itself. It will ask me what is the geometry I want to orient to the flat XY plane. I will give this surface. Then it will ask me what is a source plane. Source plane is nothing but the plane in which the surface is already existing. So the plane is kind of angular here. We need to find out what is that plane. We can't manually figure that out. We have a component that will help us achieve. It's called as evaluate surface. Evaluate surface is an analysis component. It will analyze the surface that I'm specifying, which is the ruled surface, and it will ask me for a UV point. When a component asks for UV point, you can just give something called as an MD slider and plug it in here. And once you do that, it will give you something called as frame. If I zoom in, you can see there are these small frames indicating the plane in which it is located. Just give this as a source. So geometry refers to what is the geometry you want to change the plane. Source refers to the existing plane in which it is locating. Target is XY plane. Fortunately, the default is XY. So if I just move to the top viewport, you will see all the panels placed flat in XY plane. Once we have this, let's switch to the top viewport because we are going to be extensively just working in plan to be creating the CNC laser cut drawings. So once we have oriented all of the panels in the XY plane in top viewport, next what I'm going to do is I'm going to also create a rectangle using a rectangle component. This should represent the size of the sheet in which I want each of the pieces to be nested. In real time, you will give the actual length and width of the board, which most likely would be 8 feet by 4 feet if you're going to be using a standard size. But depends like what the word material you're using, you would give the size of the board. In this example, I'm going to give a hypothetical value proportionate to the size of the panels. So I'm going to give maybe 50 as X and 100 as Y. So I have a sheet that looks something like this. Now what I want to do is all the oriented geometries here, I want it inside these sheets. So to do that, I'm going to use the component called as Openness. It comes from the plugin Openness. Sheets is going to be these rectangles. Geometry I want to place is all these oriented geometries. Now we need to wait because it's going to take some time. Like the chances of my system getting frozen is high. Normally when you're using Openness, make sure you save your files before you do that because the chances of crashing is very high. And also just leave your system like for some time idle. And it will, probably like after 5 minutes or so, you will get the result. That is only if you have a lot of panels. Right now I have a lot of panels, which is why this is happening. If I had less number of panels, like, maybe like 100, 200 or 500, it wouldn't have taken this much time. Let's do one thing. Let's maybe do it for the other example we did. It is taking a lot of time to process it. So I'm just going to try for this other example. Number of panels is 494. Okay, it should be faster. Let's maybe even further reduce it just so that, we don't spend time waiting for the result to come. So I'm just going to repeat the steps again for this particular surface. Why? Because I don't think my other file is going to respond anytime soon. So let us work on this example. Step 1, we can't have them as a panel at a specific angle. We need to have it as in the XY plane. So I'm using an orient component for that. Geometry to shift the plane is these ruled surfaces, plug it in here. Source refers to the existing plane. We will analyze the surface using evaluate surface for that. Connect the surface here. Point is a UV point. So to specify that, we will use an NV slider component. It will give us something called as frame. If it's kind of giving you a messy preview like this, it's just an issue with the display. You can go to display in the menu bar, reduce the preview of the plane sizes to something small, maybe 0.5 or maybe even small 0.2. And when I do that, we can see these planes have become a bit smaller in size. And once that is done, give this frame as a source. Default target is the XY plane, which would work perfectly for us. So if I switch on to the top viewport and zoom out to the origin, you can see I have all the pieces in the XY plane. Now, once I have these in the XY plane, step 2 is to create a rectangle, which would be equivalent to the size of the sheet in which I will be nesting. I'm going to give maybe 4 as X and 8 as Y. And again, the sizes correspond to the units you're working with in Rhino, right? So I think 8 itself is too big. Once we have these two, using the component called as Openness, rectangle will be the sheets, oriented objects will be the geometries, and just wait for a few seconds. As soon as we do that, you can see I'm getting some sheets nested inside it. I have it in, I don't know, so many number of sheets. But I mentioned a point regarding this number of sheets or the amount of material used will be optimized by Openness. But by the looks of it, you can see there is a lot of space wasted in each of the sheet. Why? Because there is a crucial input called as spacing. Spacing refers to the minimum space between two objects while nesting. So I'm going to reduce the spacing to a small value like 0.05. Again, I'm giving a hypothetical value right now, but when you are going to be sending out an actual fabrication drawing, the spacing should correspond to the tolerance of the machine. So any machine you're working with for CNC or laser cut, you can ask the vendor what is the machine tolerance. It's nothing but the minimum space required for the tool path to pass once and twice to cut out two geometries, right? So you can just ask them. Most likely it will be like 15 or 20 mm. And once you specify that, you can see it is now compressed to be just in 2 sheets with maximum number of pieces optimized. Again, there are several things we need to be doing. This is just to give you an idea. When you're fabricating, we need to know the sheet names or the numbers. So we have a numbering system as well. There are so many pieces here. We will first see what is the numbers of each of the pieces. To do that, you can just find the area of it and use a component called as point list. Again, understand it just like a concept, because when you have to fabricate it for actual conditions, there will be a few more parameters to keep in mind. This is just to give you a visual of how normally a fabrication data will look like. So this is the centroids. I'm giving some numbers in the centers. Size corresponds to the font size. Let's give maybe 0.15 and see how big it is. It in itself is too big, so let's further reduce it. Hide the centroid. I have a number for each of these panel pieces. Now I need to know the number of the corresponding piece after nesting. So same exact process I will do. I'll go to the top viewport, find the center of the nested geometries. Once I find the center, I will once again switch on the point list and connect the centroids to points, give a size of maybe 0.08, which is again the font size. Hide the centroids. If I zoom in, I will have these numbering systems. Again, as I said, there needs to be other things like, the number is nested at an angle, so you can engrave it on these pieces. And when you get it on site, those engravings will help you to assemble them in perfect order. So those are other parameters and things involved. But for now, just to get an idea how things work, I think it gives you a good brief on that. What is the name of the UV point component? The component is called as an MD slider. It's basically a multi-dimensional slider, which means you have two numbers. In number slider, you have one number. That's the difference. Right, so yeah, so that's it with pretty much the main workflows in the session. And yeah, welcome. And so yeah, so that's it with the main workflows for the session today. I hope you got a good idea of what are the things, like if you're someone who's absolutely new to the software, the main idea of today's session is to give you an idea of what are the possibilities in the software. And I think you would have been able to grasp that on how we start on with just creating surfaces, which are very organic in Rhino. And we do some parametric manipulations in Grasshopper, which is not restricted to just creating certain paneling systems, but Grasshopper can work with an entire form. It can develop into some kind of paneling systems or facade patterns, which can later be optimized for the amount of radiation and things. And also, finally, whatever you're seeing is not just a fancy output, but it is something you can, of course, fabricate it and get executed in real time. So this are some possibilities in these softwares. And if you guys are interested in getting these tools very handy and be able to work with whatever ideas and designs in your mind, I would recommend that you guys go and check out our full-fledged 11 days workshop. So I'm pretty sure that whatever I show you right now, like you guys would be able to, like if you go through the recording a couple of times, you would be able to create whatever I show you right now. But you might have certain ideas in your mind, like you don't just want to create a pattern, which is just the opening here. You would want to create more intricate patterns. You would want to introduce more strategies in your design and make your design workflow more with more parameters and more techniques that is possible in today's world with tools like Rhino and Grasshopper. If you feel the need for that, definitely do check out our 11 days program. I will just give you a brief of what we will be teaching during that time. And And we also have a discount code for those who have attended the workshop. I just mentioned how to go about towards the end. And welcome everybody. I'm glad to hear that you guys are able to, get a good idea of the software. So welcome everyone who have messaged in the chat. Okay, so just to give you a brief idea, I will share the link with you in WhatsApp. You can go through, but in terms of course, it's an 11-day course. We have different batches coming up in the months of December and January. You can see which would work best for you. Timings would be same. Each session will be for 4 hours, but it would be for a very limited number of participants. And it would be a live interactive session. It won't be a webinar format like how we have right now, where I will be teaching, you'll be asking questions in chat. It won't be that way. You will have a more live session with more one-on-one times to discuss and clarify your doubts. And it's going to be absolutely beginner friendly. So even if you're someone who's completely new, or you have an intermediate knowledge on how the softwares work, you can expect the workflow or the workshop to cover in a state where you will be equipped to work in the softwares by yourselves to visualize your ideas. That is, I would no longer be needed for you to teach what is the logic, what is the approach, or anything like that. And apart from Rhino and Grasshopper, we will see another software called as Maya. Maya is, we would mainly see it at an aspect where we can generate more complex and fluidic forms and later integrate in Rhino Grasshopper. So one of the tutors of the workshop will be Akash Clive, and he had done his master's in architectural association. So he has, while doing his master's there, he was introduced to certain workflows that is used by top architectural firms. So you would get to see how those firms like Zarid Architects or Norman Foster Architects use Maya as a tool along with Rhino Grasshopper to come up with unimaginable fluidic and interesting outcomes. And we have a couple of plugins mentioned that we cover in the workshop. Ladybug is for environmental analysis. Lunchbox we just saw, but we'll be seeing more detail on how to come up with custom patterns. Kangaroo Weaverbird, if you remember the first presentations example by Antonio Gaudi, we saw a form that was developed completely in a state of compression. So that was done using the plugin Kangaroo. We'll be seeing more architectural examples, which is based on certain physical forces and constraints in the plugin. And we have a couple of more plugins, Openness more in detail to be getting very accurate fabrication data, and some other plugins to deal with meshes as well. If you require some other plugins to be taught, you can always feel free to let us know during the registration. We will see if we can incorporate in the workshop. If not, also by the time you learn the software, you will be equipped to be understanding the plugins. So we will provide some additional resources and assist you on that. And these are just things that we offer. We have taught like 4,000 plus students. We offer certificates, but you would be required to submit a project work at the end, but certificates will be issued. And we would always be available even after the workshop to clarify any doubts or any queries you have related to this topic. Even after the workshop, a year later, you're working on a project, you would like some support from us, you can always feel free to reach out to us. So we offer a lifetime course support or maybe like a membership to our studio. And we also have a detailed everyday lesson plan. So you can go through our website to get a clear idea of what topics we'll be covering each day. So you know what to expect from the workshop. Briefly, first 3 days is going to be Rhino, starting with the absolute basics to reaching a level where you can see a lot of complex modeling. We saw just one strategy in class today, which was using Loft. There are like several different methods of creating surfaces and also extracting plans, section drawings, and everything out of the software. So we'll be seeing that in first 3 days. Next 5 days will be Grasshopper. Day 4, we'll start with absolute basics. Day 5, we will dive into a lot of different facade systems, paneling systems, and module generation. Day 6, we will be seeing mathematical equations, functions like sine, cos, and formulas that is used in architectural geometries, and also see how to use or how to understand the fabrication of parametric design, not just with openness. There are different strategies which is used. We'll be understanding the approach behind all of that. Then we have the skyscraper exercise we saw today, more in detail, how you extract the flow plates from the skyscraper, how you detail the skyscraper using different strategies, how to analyze it using Ladybug and come up with a responsive facade, so on and so forth like that. And day 8 is where we would be seeing kangaroo and generative design, similar to the Gaudi's example. Day 9 and 10 is going to be Maya. We'll see Maya as a separate tool. We will also see to integrate it with Rhino Grasshopper. Finally, the 11th session would be a presentation of your project work. So from whatever you learn on 10 days, you guys would be encouraged to work on a project work. So you will have some time to work on that. And you present it on the 11th day, where we will guide you and help you on how to do it better and what are things you can, add on to make it a more complete project. And the tutors of the workshop would be both myself and Akash, and we will be handling the different aspects of the workshop. And we also have the fee structure mentioned. Depending on which category you belong, you would know what would be the fees for you. So it's an 11 days program with 4 hours each day. So you have like almost 45 hours of training. And since you guys are going to be joining from the webinar today, we have a limited period discount of 10% for anyone who's joining from the webinar today. That is in addition to the 6,500 or whatever amount is put here. The access to that discount will be available till tomorrow evening. So tomorrow is 29th until 29th November, 12 p.m. So if you are willing to register, you can click on the register now. It will take you to a registration form. Do mention in that you had attended the workshop webinar today so that you can avail the 10% discount. Or what you can do is you can directly message me or Akash. Both of us are the admins of the WhatsApp group. You can message directly us to avail the discount and proceed with the registration. So that's pretty much about it. I'll share the link. You can go through at your own pace, see if the schedule and the topics we cover would be beneficial for you. And that is pretty much it. So can you share the files with us? Yes, of course, Besa, we will be sharing the files with you. We will create a Google Drive link and give you access to all the Grasshopper files and the Rhino files I have used today. And also the recording will be processed by YouTube itself. Actually, this is the first time we are streaming live on YouTube, so I'm not sure how the recording is going to be. If there is any issues also, we'll make sure that you get an alternative where you can view through all the topics we saw in class today. So yeah, so that is it for today's class, everybody. We have 20 more minutes. Do you have any questions that you would like to ask before we wind up? Okay, so I think that is it. So let us call it a day. And yeah, so thank you so much, guys, for joining in the webinar today. And I hope that you have learned some interesting techniques and strategies which you can apply in your design as well. And do share the outcomes with us. We would love to see what are the different experiments you have been able to achieve with the tools we learned today. And yeah, so that is it for today's class. And bye, everyone. Have a nice day. Welcome, everyone.